Hello, everyone. Welcome back to Ask a Scientist Gaming, where we combine mediocre gameplay with expert science. I'm Ken Hansen, Associate Professor in the Department of Chemistry and Biochemistry at Florida State University. I'm a photochemist slash photophysicist. I shine light on molecules and materials and then try to do useful things with that light energy, whether it be making and breaking bonds, moving electrons, moving energy around, hopefully something that's useful with it. But more importantly, joining me today is Dr. Cyprian Lewandowski. Cyprian, if you wouldn't mind introducing yourself.
Yes, hello everyone. So my name is Cyprian. I'm a condensed matter theorist. That means that I am interested in providing a mathematical description of why things do work or they don't work in two-dimensional materials in particular. So most of my job is just sitting in my office and banging my head on the desk, trying to figure out why my code or why my math is giving me something that is completely odd. So that's pretty much it.
Speaking of banging your head on the desk, what do you typically teach?
So, since coming in the fall, I am teaching 2054. So that's College Physics B. That's essentially all of the modern physics other than classical physics. That's what I'm teaching in the fall. And in the spring, I'm teaching graduate many body course, which is at the FSU. It's the most it's the last course that all of the graduate students in physics take.
All the students in physics have to take?
So that's interesting. FSU is different in a way that all of the graduate students need to take either a field theory course from high energy physics, as we would call it, so from particle physics, or they need to take a field theory course which is dedicated to condensed matter, so the area that I am. So
I see.
So it's a guaranteed audience which cannot run away. Yes.
So you at least have a dozen students. Right?
Yes, that's right.
That's kind of nice. All right, equally important, what game are we starting with?
Okay, so I thought that we could begin with Counter-Strike version 1.6.
All right. Are you ready?
So I am ready, and we can try.
Oh, go ahead and click start.
Okay.
Let's dive in. And so you decided you're going to play against bots.
That's right. I want to play against bots for a while until I get better, and then, or if I don't get better, then
continue against bots.
We will continue against bots, and the bots are on easy mode. So that's really all that I need to know.
So how long has it been since you played this?
So I played it in secondary school a lot. So that would be when I was maybe 13, 14. Yeah.
But you were into it then? You were
well, we would play a lot with friends on a break every now and then in a class. So particular maps like this are kind of etched in my memory.
What's funny is, so I never played this game, but this was one of the earliest esport games, right? Where they were competing for $1 million prizes. And so, believe it or not, I also know these maps just from watching it. Because this one's disarming the bomb behind the boxes up on the platform.
That's right.
Yeah.
So they put the bomb on, I think, the different... Wait, are we lost? Okay. There's a guy here. Oh, there's two of them. Okay, and we lost.
You traded. Off to a good start. You feeling it?
That's right. I'm thinking B3, 2, and that's pull up. Okay. Yes.
Okay, let's go.
Oh, and they're talking to you too.
That's right. So I think when you play with bots, you are kind of the commander.
I see.
I don't feel in the leadership role, so I wish that they would lead, and I just...
So do you control the bots, like what they do, or?
I think you can, so there's a way of giving them a command, but I forgot what it is.
No worries. Yeah, and anyone in chat, if the volume's too loud or too quiet, let us know. We're trying to balance the game audio versus talking. And it's hard to balance bullet shots versus the casual background noise. So yeah, if it gets too loud, let us know. Please feel free to comment in chat. I feel like it's coming back.
It's coming back a little bit, but I think they planted the bomb one more time, and I'm down on my teammates. Yes, I am the last person
Cuddle Puppy brings up an important point. War zones are supposed to be loud. All right. So that's a good justification for being loud. Cuddle Puppy, welcome back. Data Basics, welcome back to the stream. Thank you for joining us. Emmy and Max.
Oh, I know.
You know sorry? Data Basics, Emmy and Max?
No.
Cuddle Puppy's going to be exceptionally cynical today. I wonder why. Our goal is not to get Cyprian deported, so you use chat accordingly, Cuddle Puppy. Oh man, I wish I laughed to hide the pain. All right, Cyprian, while you settle into some gameplay. Oh my gosh. So do you automatically lose if you get killed, or can your team still
So my team can win, but I think they are gonna let me down.
It's a cynical day, as noted by Cuddle Puppy.
Yes, you see? Yeah. So I have one teammate left, and there's one enemy left.
Yeah, and he's just shooting into random.
Bomb planted, and let's see what my teammate is going to do.
This is where those commands would be really useful. Oh,
and we're done.
All right. Next round.
Next round indeed.
All right. As you're diving into the next round, the question we'd like to start with, and this is because a lot of students think we were born for this job, right?
Okay.
From day one, we thought we were going to be, an expert in chemistry or condensed matter physics or whatever it may be, and that is rarely the case. So, in all likelihood, 6-year-old Cyprian was not envisioning himself playing video games, talking condensed matter, 2D material, theoretical modeling.
No.
So, many twists and turns in your life path brought you to where you are today. So what were those life turns and paths, and what were the, if you remember, key moments where it was like fork in the road physics, and then fork in the road condensed matter physics, and then graduate school, postdoc, so on and so forth?
Okay, so that's a good question. So maybe I go starting from PhD backwards, because that is easier for me to think of. So to be honest, it is very common that people, and myself included, we actually don't hear of condensed matter at all until the last year of undergrad, or so pretty much many of us just learn of condensed matter in the last year, and for me, I kind of knew that I wasn't particularly good in the lab, so I knew that I wanted to do theoretical science, but I didn't know which theory should I focus on. Mm-hmm. So I did a bunch of different theory projects. Firstly, after my firstly, I did a project which was in high energy theory, and I kind of realized that this is not the area that I like. So then I was lucky enough to get an internship, a summer internship in the US, working in the area of condensed matter, and I kind of enjoyed that. So that's how I ended up in this field, and then I went to a PhD program, and and one thing led into the other, and I am here now. But more important, I think, was the decision: do I want to do theoretical physics or normal or not normal, but experimental physics? Mm-hmm. And that, I think, happened to me last year of in high school, where I noticed that I wasn't really precise, maybe, to do all of the experiment, but I enjoyed the math more, and that's how I decided on theory. But then why physics? So actually, in my secondary school, when I first began. When you are taking physics classes, I was very bad in physics. So physics was my by far worst class. And then I guess I just dive into it a lot in order to improve my grades, and over time it became a class that I like. Yeah.
That's awesome. Yeah, so you decided sciences pretty early? When was that?
That's right. Yes. So I decided sciences very early on because I noticed that I was fundamentally opposed to essays, only to learn that as faculty, what I do is pretty much write essays all the time. So yeah. So
Yeah, the joke on you. You got a job writing stuff.
that is right. Yes.
I literally spent like 4 hours today writing. Like it's letter of recommendation season plus, yeah.
That's right. So,
Oh man.
yeah, so that was kind of I'd like to think that if I, for example, did something which was more essay writing oriented, that perhaps I wouldn't do so much text writing than I do now. But now it's just insane the amount of text that you write. Yeah.
For those of you that don't know, like as professors, we don't do a lot of experiments in science anymore. I mean, well, you're still starting, so you're still pretty involved in what's going on. But
that's right. Yeah.
I guess as theoreticians, it's much more likely. Like David Collins still does his own programming and
Yes.
things like that. But man, for me, I haven't done a wet anything in like 8 years. I haven't touched a chemical. I haven't done a synthesis. And I kind of miss it, actually. Like there's something to be said about boots on the ground. Oh, so what was the button for disarming?
E, if I remember, but to be honest, I didn't remember. It was all more of an yes.
That's amazing. You felt it in your bones.
That's right.
What did we say? It's been how long? 15 years?
Maybe, yes.
Wow.
Yes. So now
Good on you. So you guys won a round?
we want to. So we are crushing it, I guess. My teammates and me are working better.
I wonder if people are streaming Counter-Strike. Counter-Strike 1.6, right?
That's right. So
Oh yeah. There's several people. It's got a couple dozen viewers.
I'm down. Yeah.
Yeah, watching the pros play this, they're absolutely surgical. It is
Yes.
amazing.
But it's an interesting thing to ask, because I think that so I did my undergraduate in the UK, and in the UK, unlike the US educational system, you choose your major when you're applying to the university, and then if you want to change the major in your undergrad, then very often you need to reapply
To the university.
That's
Wow.
right. This is.
What was your undergrad?
So my undergrad was physics with theoretical physics, which is just a way of saying it was physics with more math rather than more lab.
I see.
And I sometimes ask myself, to what extent the choice I made was informed. Like there was no way that I would have known at the age of 18 that this is what research in physics is like.
Yeah.
And it's more that it's I think you choose an area that you think that you would enjoy based on
That is amazing.
yeah.
Sorry.
Nice.
Oh my god. All right, sorry, you're picking an area you enjoy. That was an amazing bot face off right
That's
there.
right, yes.
That's what easy bots do.
My teammates.
Cuddle Puppy has a compliment. Dr. Lewandowski is fantastic. He just needs to work on communication, aim, map awareness, crosshair placement, economy management, pistol aim, AWP flicks, grenade spots, smoke spots, pop flashes, positioning, bomb plant positions, retake ability, bunny hopping, spray control, and getting kills. If you get all that down.
So wait, I have a question. What is bunny hopping?
Cuddle Puppy. Are you a counter striker? I've seen it before. You just jump around, right? I don't even know what the jump on
Is that a bunny hop like this?
Yeah.
Oh.
Cuddle Puppy, if you want to elaborate and coach Cyprian, he's happy to learn.
That's right. But so in my defense, I have not played this map a lot, so I kind of haven't figured it out yet. Oh, look. Yes. Good job, Cyprian.
Bunny hopping.
Bunny hopping, yeah.
Oh, so you murdered everybody? That was...
No, not me. If you look at my team, I am not the leader in terms
Wow.
of the. It's a bot norm.
Oh, interesting. It's when the jump animation has quirks that allow you to build up a huge amount of speed by hopping repeatedly. Oh, interesting. Can you do that in actual gameplay? They had to have patched that out, right?
Funny.
Like, I can't imagine that being used in tournament play. But that's pretty cool. I love glitches in video games. It's finding the hole in the matrix. Nope, it's part of the game, so it's apparently legal. So I imagine the pros are just doing that all over the map.
That's right. I also remember that there was this thing that if you change to a knife, you run faster, because somehow then the mass of the gun is not as big, even though it's on you. I don't know really what was the logic on that, but...
Oh, Cuddlepuppy has an important point. Remember, this game is based on Half-Life 1, which was a super fast arena shooter. Yeah, I remember that one. Did you play Half-Life 1 at all?
No.
I guess it's the same physics engine or something like that.
That is right. So in fact, if you dig into the move, teammate. Okay. Headshot after headshot. Right.
Counter-Strike was literally a Half-Life mod.
Okay.
That's fun. The early days of modding.
Oh,
It's like Dota 1.
that's right. So the Dota 2.4, I guess, was the map. So yeah,
It's pretty fun. How many maps are there for this?
I don't know. I think that there is also a way that for you to build your own maps, and I remember there was a designer that you could build. So I remember doing it, you know, as a kid.
Yeah. So back in the day, how many
Yes.
were there? Probably like 5 or 6.
Oh, way more.
There was more. Okay.
Even then. So, but now these are some different maps.
That's what makes it fun. That's great. All right, if you guys have any questions for Cyprian, he has settled in. He's played a little bit of Counter-Strike, won some rounds, getting the feel back, getting the
That's
controls,
right.
the instincts. He got disarmed just from like genetically written controls of Counter-Strike. So he's happy to answer any questions, particularly condensed matter theoretical physics, condensed matter physics in general, superconductivity, plasmonics, 2D materials, atomically thin materials, stacking atomically thin materials. He's happy to answer any of those questions. So I'll start with one just to give everyone some context. So you care about ultra thin materials. Why are they interesting? Why should the audience care?
So, okay, so if I were to give a practical answer, I think is that in normal three-dimensional materials, the amount of electrons which you have in a material is fixed. It's kind of set by properties of your material, since most of the materials that you encounter in nature are charge neutral, and very often it happens that a material might have interesting electronic phases or some interesting properties if you were to modify the number of electrons in a material. And in a normal material, which is three-dimensional, typically the only way how you can do it is that you need to do chemical substitution, so chemical doping. So, for example, you change a particular fraction of atoms in a material to a different number, and that generically means that for every, let's say, doping, you need to make a new material. Now, in two-dimensional materials, this is not the case, because two-dimensional materials, they can work a bit like a capacitor. So I don't know, the audience has some background in physics, but a capacitor is this idea that you have two metallic plates, and by adding a difference in electrical potential between the two metallic plates, you can actually build up charge. So this lets you set up a system that you have a gate, which we call a metal, and then you have your material that you're interested in, and you can then easily change the amount of charges in it. So this makes these materials easily tunable in terms of the number of charges. And then the other thing which is interesting is that now that it's a two-dimensional material, so you can access it not only using what we would call the transport probes, meaning that you connect one lead, the other one, and you measure resistance. You can bring different local probes, or you can shine light on it, and you can study its properties. And it so happens that these two-dimensional materials very often have many interesting properties that are technologically viable, and it's a new frontier in terms of potential technological applications.
Yeah, so graphene, what was that? That was Nobel Prize in what, 2010 or something like that?
That's right. So graphene was a Nobel Prize in 2010, and it was first exfoliated in 2004.
Which is crazy for a turnaround for a Nobel Prize.
Not
this year.
Not right. This year, right? Which was 2 years, I guess, the turnaround.
Oh, they're still very young.
That's right.
Yeah, usually it's decades for it to have an impact, but graphene.
Yeah, but part of the reason why graphene was why it hit the whole world by a storm is that it not only made the graphene so interesting, but also because it kind of pushed the interest of the general public into the two-dimensional material. And it actually made this practice of electrostatic doping, how I would call it, a common practice. And in particular, the Nobel Prize winners, Sir Andre Geim and Sir Kostya Novoselov, did this very nice thing, which is not that common, is that they invited everyone who wanted to their labs to be able to learn how you make these graphene devices. So perhaps unlike other areas of condensed matter where you would secretly not share what is your method for making the devices, they were actually open to it, and I think that was a big boost. Yeah,
no, that's a fun turnaround in terms of time to Nobel. But has there been a product with graphene in it?
Okay, so that's a very interesting question. So in 2010, I think there was a EU, so European Union funds these so-called flagship topics of research for 10 years, I think, if I remember it right. Mm-hmm. And they funded graphene 1 billion euros for 10 years. So meaning that different PIs could send proposal involving graphene. And of course, the technological application was something that needs to be an outcome of this. And to my knowledge, there isn't really yet any viable outcome in a sense of commercial technology. Mm-hmm. You can certainly buy things which have some graphene in it, but the graphene is not really doing much. Graphene it adds it wow factor. There's one interesting product which was on a Kickstarter, which was a toaster, which part of it was made from graphene. And a reason that that this is interesting, and perhaps we will come to it later, is that it lets you see the bread as it's being toasted. And if I remember right, you can actually check it on Kickstarter. It was one of the people who were who were supporting it was also the Sarkostian Novoselov, I think, if I am right. Yes. So
First graphene powered appliance.
yes,
Is that it?
yes.
All right. This stream brought to you by Kickstarter. Here's if you guys want to invest in a. I mean, what is the graph? It's the thermal conductivity they're excited about in this case, or the
and also I think this transparency that it can be metal, which simultaneously lets light through.
So it's heating through the transparent part,
Yeah.
through the thermal conductivity.
As far as I understand, so
That's what the video leads me to believe.
I mean it was, but for example, this is not the before graphene there was carbon nanotubes, right?
Yeah.
And you can ask the same thing: what are the practical applications of carbon nanotubes? And to my knowledge, but maybe someone can correct me, is that we actually use it in random access memory for satellites sometimes, because it's more resilient to space radiation than normal memory would be. But yes, but it's a big challenge that not that much has moved to the industry. And
I mean, what's amazing about this Kickstarter, sorry, going back to this, is they've had 23 people pledge $24,000. So they're donating on average, $1,200 each to make this thing happen. Presumably they want one of these when it's off the shelf.
yeah.
That's pretty cool.
But so I'm sorry for going on a tangent, but for example, you could ask the same about gallium, right? So gallium arsenide is also, it was an amazing metal before graphene and so on, and you could ask, why are we not building processors from it and so on? And part of the reason is I think is that there's just so much money invested into the technology of building silicon-based devices that the advantage is not that big, I think.
Yeah. I mean, you got 60 years of process engineering and industrial engineering, and it's pretty hard to replace dirt, right? And sand.
Yeah. So, oh wait, I have this a hostage following me because I rescued it and I don't know where to go.
Oh, is this a hostage rescue?
That's right, but I don't know where is the safe zone, and I don't remember how to see a map. If there's
Cuddle puppy, help!
Because otherwise I am just running with him, and I don't know.
Oh, Maripan, first time chat. Thank you for joining us. Oh, when you're talking about the capacitor and asking what they know, Maripan said we don't.
Okay,
but this is a very clearly explained thank you, so that's awesome. And Maripan followed up with, it can do everything except leave the lab, so to speak.
I have a t-shirt like that.
But give me money.
Yes, so I have a t-shirt which says graphene can do anything except leave the lab. Yeah.
I mean, so that's an interesting... Oh, Cuddle Puppy, I've never played CS1, so I have no idea how, basically I have no map or HUD.
Okay, so I mean, I'm just running that timeout. So I think I am the last person in my team. There are 2 more people, and I kind of need to. Okay,
Just gotta murder them, then you win, right?
That's right.
1.
Okay.
Check.
Okay, and we won. Yeah.
I mean, so that's one of the interesting things, because there was this discussion when C60 won the Nobel Prize, right? Harry Kroto and Curl and what's the third guy? Don't remember his name off the top of my head. But it's one of those, like, if you look at Alfred Nobel's will, it was the advancement of science for the betterment of mankind. And betterment of mankind is loosely defined, right? Is it that it inspired a new area of nanotechnology, or did it actually do something useful for mankind? And so the Pokeballs had a similar promise, but not necessarily delivered on it, right?
Yeah.
Do you think long-term graphene will be the thing, or just 2D materials in general?
I think 2D materials in general will be important, because in particular there's this notion, which I guess I should have mentioned when you asked me why 2D materials are interesting, that you can put them one on top of the other. And when you do that, let's say you have a material A with particular property, you'd have a material B with a different property, and when you combine them, sometimes you can transfer properties from one material to the other, which is perhaps what you expect, but sometimes you combine A and B and you get something vastly different. So it's this
Give you unique things you can't get any other way.
So it is this idea that other than relying on nature to give us the materials that we want, we kind of can almost engineer a material with desirable properties. And part of my research is to actually learn how to imbue the desirable properties on materials that people are interested in. And
I mean, so my understanding as an experimentalist, one of the fundamental limitations of some of these materials is just how hard they are to process and make devices and control. Like making a single device, you can do that, right? If you have SDM tips and stuff like that. But trying to manufacture this on scale is, my understanding is that's just a fundamentally hard problem right now.
That's right. So there are two types of graphene. There is this graphene which is essentially they got all of the guys. Okay, where are we going? Okay, so there is
all of them. They'll show you.
There is this graphene which is taken by exfoliation, meaning that you essentially take a bit of graphite, you apply a tape to it, and then you detach it, and you have a single layer of graphene. And such flakes are very large, or can be made very large, micrometer in size, but they are very clean. But of course, as Ken is saying, that's not what we want, because you can't imagine a manufacturing process.
Got tapen.
So part of so the way how graphene is, and there's a serious amount of very serious people who are interested in this, is that you grow graphene with chemical vapor deposition, CVD growth, and you can make now big batches of it. The problem, and they are consistently improving this process, that this graphene is not as clean as the graphene which you get from exfoliation.
Interesting.
And then, but you can imagine that at some point when they come up with these graphene, I want to say meters of it, which is CVD grown, and it's sufficiently clean, then people can design procedures how to
by clean you mean like defect free, perfect carbon pattern.
That's right. So yes.
Man, there are certain like thermodynamic limits to generating that, right? Like in terms of entropy and growth, and like, do you think it's possible to do that via vapor deposition?
Okay. So you are asking a theorist. So
on paper, does it work?
I think on yes, but I don't, to be honest, I don't know really.
And that's inspiration for the audience. I mean, how much do you think that idea is worth? Somebody can grow meter by a meter of perfect graphene in controlled matter. Does that revolutionize the industry?
I mean, I think if you grow it, and then you come up with all of these different ways how you could make, for example, chips. Then yes, but
yeah, that's fun. I love the fact that like anyone with a pencil and Scotch tape can make this happen. They can't make a device, but they can exfoliate
Yeah.
at least a little bit of graphene. I mean, it's probably mostly multi-layers when you actually extract it, right?
And that is right, but you can absolutely get a single layer too, and because these two-dimensional materials, unlike normal materials where the layers are bonded with strong covalent bondings, they are actually the bonding is in the plane, and then the different planes are attracted to each other via you can tell us more about these van der Waals forces. So these are much easier to detach, and so people actually detach one. So it's true that if you apply the tape and then make this exfoliating motion, you will get a bunch of different thicknesses, but you will also get single flake. And
as long as you pick those singles, then you can do research on them. Devices and whatnot. That's pretty fun. Yeah, it's a fun factoid for my audience. The just Scotch tape. How useful is that?
That's right. Yes.
Yeah, there's an adhesion test. That's something. It's called the Scotch tape test, depending on how strong your material adheres. So, like, Scotch tape has been consistent for like 20 years or something. So this is a metric that people use with material adhesion properties. It's kind of fun. So yeah, worth the Nobel Prize. All right, but yeah, if you guys have questions for Cyprian, he's happy to answer them. Talking about 2D materials, talking about condensed matter physics in general. Condensed matter physics, how would you define that to a general audience?
So to general audience, I would define it as the area of physics where we are interested in understanding of properties of materials, or when many electrons, many particles come together. So in other areas of physics, for example, like particle physics, there's this tendency that you want to isolate individual particles and understand how they interact with one another. But in condensed matter, we realized that the number of particles in a system is 10 to the 23, which is a large number, and we can never model it. We can never describe all of them. So we are trying to come up with an effective description which lets us understand properties of such a system better. Yeah.
I love the partitioning in the physics world, because you have the three main branches, right? Astrophysics, condensed matter physics, and then high energy particle physics. and as you described it, it was like particle physics is looking at one particle at a time. Condensed matter physics is looking at, we'll say a mole of particles, and then astrophysics is all the particles.
That's right, and it's a little bit also it's divided by the by also the relevant energies. Is that, for example, for particle physics, in order to learn something now, you need to work with a particle collider, where the particles are accelerated to huge speeds and then smashed together. In astrophysics, the problem is to a large extent sometimes classical, so you don't need to use it, or quantum physics, but it's very hot, right? And then in condensed matter is many particles. It's very cold by comparison to astrophysics, and nothing is moving too fast. Nothing has too much energy. And then of course there's a nuclear physics, which you would say it's in between. And then in condensed matter you have a hard condensed matter, even though it's, and then you have soft condensed matter, and both soft and hard condensed matter can be difficult, even though the name is hard. And the difference is
4v1.
It's on them. So and the difference that the hard condensed matter deals with properties of materials where quantum physics is important, whereas soft condensed matter deals with maybe more classical properties of materials, what happens when you deform them, um, and yeah.
I like your framing there. Condensed matter physics is slow and cold compared to astro and high energy. No, it's different levels of abstraction. I like it. Yeah, I've served on a lot of condensed matter physics committees, right? For like Hanwei and anyone doing, that the experimental photochemistry stuff. But also I've done some astrophysics, like David Collins. I've been on a couple of his committees. It was like 2 weeks ago I was on my first high energy particle physics committee. And so they were talking about, it was Ted Kohlberg's student, and they were talking about studying self-coupling and Higgs bosons and like the energy and whether that just follows the standard model or not. I have no idea about any of this stuff, but it was interesting because I learned a lot.
Yeah, so condensed matter is more qualitative in nature. We are interested whether there is an effect or there is an effect, typically. Whereas in particle physics, the accuracy of those experiments and corresponding theoretical model is so good that it's becoming a precision physics. But the point is that because you are so precise, you might be able to notice that there are certain differences between what your model predicts and what is seen, and there's some new hidden physics in these discrepancies. And I think condensed matter hasn't gotten there yet. And it's a different discussion whether we actually ever will, because it might not be possible to.
Oh, it just becomes intractable at some point. Huh. Yeah, that was one of my favorite things about the particle physics one, is they have this kappa parameter. They describe the experimentally measured self-coupling of the Higgs boson versus the standard model self-coupling. And that kappa is essentially a fraction of wrongness. Like, how wrong is the model one direction or the other? I'm like, that's awesome. And they're just trying to narrow down the error bars on that kappa. Like, can you get an exact answer? And if it doesn't agree with standard model, physics is broken. And that's pretty fun. Well, my favorite thing about that, I mean, going full circle, is when you look at the CERN like detection capabilities, it's a whole bunch of CCDs plus thermal detection plus, and it's all a byproduct of condensed matter physics theory.
That is right. So part of the condensed matter physics is that whenever there's a experimental discovery or theoretical discovery which is useful, then it very often leaves condensed matter physics very fast. So it goes towards engineering or towards material science. So that's why maybe the focus of condensed matter is more on searching for qualitative effects, and then once you find them, then they kind of leave condensed matter, which
Then they become a Kickstarter.
Well, okay.
Making toast. Sometimes.
Yes.
Oh, that's fun. So how are you feeling about gameplay? You're playing a bunch of new maps you've never played before?
That is right. So these are not the maps that I know, and I don't know the commands to change to a different map, but I hope that we will get one of the maps that I know. So I only knew the first map, D-Dust, and now and this one I don't know even what this is.
Anyone that's never played a first-person shooter before, number one thing to get any competitive edge is to know the map.
Yes.
You have to know what's behind you. You have to know the paths. You have to know angles, and if you don't know that,
that's right.
Should I look up how to change maps? Do you want me to take a look?
You can, yes. I think that there was a command. So, but I think you need to type I 1.6.
1.6. Okay, yeah, it's giving me.
Yes, there you go. The change. Okay, change level. I see. Okay, so we type change level. Okay, and now, for example, I would write.
Oh, you have to know the name of the map.
That's right. So I know just this one. For example, this is the one that we just played. But
do you remember the names of the other ones? You want me to look them up?
one is called Italy, but I forget what is the letter before. Counter-Strike
1.6 maps.
Italy map. Okay. Keep going down.
Because Dust 2, those are common.
Right. Can you go for this one?
Which one? Hostage?
Yes, Hostage Rescue.
Just that.
Okay, so can you type in Google the Counter-Strike 1.6 Italy map?
Strike 1.6 Italy. Map. Italy, not spelled correctly.
Yeah, it says.
Yeah, it's called Italy. CS Italy.
Italy, thank you. Okay, so we will go to this. CS Italy.
Old Man Thelonious, first time chat, welcome to the stream. Thank you for joining us. I have not played this in a long time. Still a good game, in my opinion, absolutely. Turns out Cyprian hasn't played it in a while either. We're making it up as we go.
That's right.
How's it feel, though? Like, compared to your peak skill level, where are you at right now, percentage-wise?
Low. I am not saying that I was ever good. I was, but yes.
Yeah, so we're playing against bots just because it's much more controlled and you can switch maps and things like that. But old man, I agree with you. This is a spectacular game.
So
So
for example, here you would typically try to kill the chicken.
Instead of bonus points.
But I didn't manage. I was killed before.
I love that you got murdered before you went after the chicken. You just got sniped. Oh, I like it. But yeah, if you guys have questions for Cyprian, he's talking condensed matter physics, materials, hard, soft materials. He's a theoretician, so you make models, you describe materials, you try to predict properties. In particularly, if you take atomically thin materials, which are sometimes referred to as 2D materials, very, very thin, have unique properties, and then you stack those on top of each other and they have even more unique properties. And so you're interested in developing those. So how many people experimentally actually start stacking 2D materials?
I think it is. So I think in almost every major university, you will have at least one group that is doing it.
Yeah.
And it's kind of an easy barrier of entry that you can make these devices, but the problem is that very often the physics, which is interesting, it only appears at cold temperatures. So the difficulty very often is not just making the devices, but being able to cool them down. So that is the challenge. But if you're a theorist, then actually the model writing for these systems is very easy at first, and that is part of why graphene was so popular, because the in normal materials, our particles, our electrons, they would behave as what I would call point-like objects with parabolic dispersion. So their kinetic energy, if you remember, is half mv squared. But in graphene, that's actually not the case. It's let's say it's linear.
Interesting. I did not know that.
Yeah. Huh. So part of the reason that people like graphene is that the electrons in graphene have the linear dispersion, which is exactly what you expect for photons. So people, due to Einstein's relation, E equals to P times C. So people were enjoying this analogy between photons and electrons in graphene, and saying that graphene is like a very low energy version of the high energy physics. So you don't need to build a multi-billion
Slow and cold.
Yes, yes, yes.
I like it. Contra, thank you for the subscription. You bought us some drinks tonight. That is spectacular. Comment from Contra is, hey, docs and friends, thank you for the chat so far. Regrettably, dinner is done and I have to run off to and work because deadline. Completely understandable. Thank you for joining us as always. That Kickstarter is crazy. I remember having some fun with YouTube DIY graphene making experiments once upon a time. In fact, one of my piano students went into material science at UTD because of it. Really great discussion. Thank you. I'll catch the rest of the VOD and I'm going to lurk. Well, if you're seeing us on YouTube, thank you again for the subscription and the comment. Yeah, the DIY graphene stuff is pretty fun.
Yeah.
I love that a piano student's like material science is where I'm going. That's pretty fun. I mean, so you're a theoretician. Oh, King Willie. Hi-oh. King Willie, welcome back. Always a pleasure. Thank you for joining us. If you have some condensed matter physics questions, Cyprian's happy to answer them. But sorry, so following up. So you're a theoretician. How closely do you work with experimentalists? I mean,
okay, so as theories go, I actually work very closely. So there are many theorists who actually approach condensed matter more like a mathematical field. So they actually don't interact at all with experimentalists, whereas I work a lot. So in particular, like almost 50% of all of my papers are with experimentalists, where a certain effect is being seen, and I am being asked to develop a theory model, and I actually like this because, you know, it's very rare in theoretical physics that you can come up with a model and you can check it in someone's data almost immediately. And that's the ultimate check. Do we understand what is occurring in the system? Do we really understand why these electrons are behaving this way or the other way? By chicken.
you got a bad time.
Yeah. So
I chicken.
So this is something that I do like. Yeah.
Yeah. All right.
And also the other thing is that you realize that as a theorist in a field of condensed matter, you will never be able to capture, you will never be able to model the data perfectly, right? Because it's just too many things that are involved in the problem. So you are trying to distill or identify what is the key effect that you are after, and then you are trying to build the minimal model which kind of captures the physics, and then in the words of Dirac, I think, is that you want the theory to give you more than you put in to develop it. And then it's a good theory problem. And for me personally, I like condensed matter theory and any theory because I enjoy learning new math, and very often the difficulty in condensed matter theory is trying to figure out what problem do I ask, and then once I ask the problem, how do I frame this problem in terms of math. And you know, and you find that you need to learn something new. So a famous example from physics in general is that when quantum mechanics was being developed, physicists noticed that, okay, I must come up with this I must come up with these objects that when I, let's say, times x times p, it's not the same as p times x. So in quantum mechanics, some of you may have heard of it as this Heisenberg uncertainty principle, for example, x. And physicists in the 1915 didn't know what mathematical object can have these properties, and then surprisingly mathematicians knew it, and to them it was obvious. So the physicists needed to learn that there are these concepts like matrices, and they have this property of non-commuting, so A times B is not equal to B times A. And from that on, linear algebra, so the mathematics of operating on matrices and vectors, became part of every physics curriculum. So this is the part that I like, that you learn new mathematical tools. I guess it's pretty cool.
That makes sense. Old man Polonius. Sadly, the university I was kind of still am at was focused on high energy physics and had no ability to do condensed matter work, a lack of cold. Need to find an institution where I can put high energy stuff behind me and explore BECs in particular. BECs? What is BECs?
Bose-Einstein condensed.
Oh, yeah. No, that's fun. Old man, I remember you talking about this last stream when we raided you, talking about, you're doing high energy physics and you want to do some condensed matter. So that's fun. If you guys haven't checked it out, there is a strong group of educational related streamers. Old man Felonius talks physics and a whole bunch of other stuff on stream. So check him out there. Thank you for joining us. It was 2 weeks ago we chatted about some physics. So
I can just follow it up. So I don't know what is your background, but for example, so part of my work is that I work at the National High Magnetic Field Laboratory. And National High Magnetic Field Laboratory, the MagLab, is a user facility, meaning that everyone can submit a proposal to measure something. So, for example, very often, even if you don't have the lab to make something, you could, in principle, come here to the MagLab, do the measurement, sometimes even make the sample fabrication here. So if you have a concrete proposal, then you can submit it to the MagLab panels, and they could review it. So that's one way of maybe making the experiments which you, if you don't have the facilities in your university.
Am I crazy, or do we have Italian opera going?
That's
on
right. So there is this a radio which is singing.
I see. The closer you are, the louder it is.
Yes.
That's fun. This game's realistic. I like it. That's amazing. All right, King Willie. Since weapons in Counter-Strike operates on hit scan, which involves spawning a straight line from the barrel of the gun to the target without involving actual projectiles with physics or any other variables, does that mean Counter-Strike is one-dimensional?
Oh,
are you familiar with this hit scan?
No. What was the idea?
So there's some games where it might like calculate, where the bullet's going to go or what its projectile, like its Newtonian arc and things like that. Hit scan is basically, is the crosshair on the person?
Yes.
If so, then it hits. And so you could be strafing, but as long as you shoot it straight, it hits them.
So I think individually, each with the moment that I engage the shooting, I think then it becomes a one-dimensional problem, right?
Yeah.
But I think other than that, it's just
That's fun, King Willie. Thank you for that. I did not know this was hit scan. I'd never actually looked it up. We'll count it as one-dimensional, momentarily one-dimensional.
I guess I guess this was easier to implement than try to do the.
Blame it on Half-Life, right? But this, one of the originals. And which I don't know if you know, King Willie, which first-person shooters don't do hit scan? Who actually calculates it's got to be more modern games, right? Very curious. All right, we should do a prediction. Which one do you want to do?
Let's go the very first one.
First one. All right, ladies and gentlemen, we're going to do some predictions. For those of you not familiar on Twitch, we have predictions. Usually they're related to games like, will Cyprian win this particular round? But yeah, on Ask a Scientist Gaming, we force our guests to do work. They come up with a bunch of questions, and then we bring those questions to you guys, and you get to use our standard internet points, which are imaginary points on our channel. We call them standard internet units, and you get to gamble them on science-related questions and the expertise of our guests, something they might want to talk about, or something they find interesting. So we're going to pop up a prediction, and you guys will get to test your scientific knowledge. Note you're on Ask a Scientist Gaming honor policy, so you can't use ChatGPT or Google or whatever. Instead, use what you know or what you know of Cyprian to answer the questions. So, first question we're going to pop up. How fast are electrons in a typical wire? Faster than a garden snail or slower than a garden snail? It's just a typical garden snail of some kind.
Yes.
I don't think the error bars matter too much on the speed of a garden snail. But if you guys look at your chat, on the top of your chat, there's a predict button. Click that predict button. Go ahead and put your predictions now. And you can wager as many of our standard internet units as you want, depending on your degree of confidence in your answer to this particular question. So, yeah. Do your predictions now. You guys have 2 minutes from the start time. You have about 1 minute and 30 seconds left because I talk a lot. All right. So yeah, that's the spiel. Anything you want to add to this? I think it's pretty straightforward, right?
That yes, I think that this is. It's just
So what I love about the meta of this kind of question writing is because you could go the other extreme and like faster than speed of light or
Yes.
faster than speed of sound. Why did you choose? Well, we can get into it later, but I'm curious how you landed on garden snail as opposed to maybe a cheetah or what other creature you want. But we'll do that after we answer the question. But yeah, make your predictions now. Again, depending on your degree of confidence, you get to weight your decisions accordingly. Well, that's fun. Old man Felonius is following up on the MagLab discussion. I've done that sort of experimental access thing with proposals at Fermilab. I was surprised because I'm Canadian. Perhaps we were a bit further down the list, but we got time to go and beam configuration we needed to test the beam facility. Very exciting work. Got my first peer-reviewed paper with the data we got. Anyways, thanks for the heads up on MagLab. I'll look into it. Yeah, there's a link in chat if you want to check it out. It's pretty fun. Huggy Beer, it has been a while. Welcome back to stream. Thank you for joining us. We're shooting some chickens in Counter-Strike. Maybe winning a few rounds. Cyprian's playing for the first time in like, what do we say, 15 years or so? Falling into it. You having fun? Like, is it?
That's right. Yeah, it's fun.
It's not like playing with friends, but man, it's fun.
It's just whenever you say this number of 15 years, I realize, oh yes, I am over 30 now.
No, it's crazy. So this game came out in 2000. It was early 2000s.
2001.
It was 2001.
I think
Okay,
so, yes.
so it's very similar, timeline to Halo and a lot of those first-person shooters. All right, Cyprian, what's the answer? Faster than a garden snail, slower than a garden snail?
It's slower than the garden snail.
So how does that work? My light turns on pretty quick.
That's right. So this is a classic problem. So it's kind of like if you have a water pipe and I turn on the water pipe, at the wall, the water begins flowing at the end of the pipe almost immediately. And the reason is that even though the individual water molecules are moving very slowly, it's just the push of all of the water molecules forward that actually pushes the water. And in this particular case, electrons are charged. They have they are negatively charged, so one electron pushes other electrons away from each other, and that interaction is mediated at the speed of light, and that's why it's immediately that when you turn on the light switch, your light turns on almost instantly. And the way how I came up with this is that I knew what is the number roughly, and then I thought, okay, so that is very slow. Let me think what objects do I know that move so slow? So this is if you show my answer so that I don't mess it up. So an electron in a wire moves at 0.0004 miles per hour. whereas a snail moves at 0.03 miles per hour.
It's 2 orders of magnitude
Yes.
faster, actually.
Yes. So that's an interesting, interesting comparison. Which kind of makes sense from a point of view that there are so many electrons packed in a wire that they bump into each other, and they move very slowly. Yeah.
That is fun. All right, so 2 orders of magnitude slower than a typical garden snail. One thing I like about the answer, particularly these numbers, is humans have both measured the speed of an electron and the speed of a snail and have reported them somewhere in literature at some point.
Yes.
Which is amazing. Huggy Beer has a follow-up. The electrons move differently for AC versus DC, right?
That is right. So for so for DC, you can think of it that the electrons are pushed one way only, but for AC it's oscillating in a sense. I'm pushing it forward, backward, forward, backward, forward, backward, and that oscillation is sufficient because all of our equipment also operates on this forward, backward idea. Yes.
But the individual electrons are still 0.00004 miles per hour?
Right. Yes. I mean, this varies from a material to a material, but the general number, yes.
Yeah. No, that's pretty fun. Thank you, Huggy Beer, for that follow-up. Abydos, welcome. Abydos, I hope I'm pronouncing that correctly. Welcome to the stream, first time chat. Thank you for joining us. If Old Man Felonius pointed you this way, that's awesome. Thank you for joining us. Misadventures in Astro, welcome back. We got another physicist in the house. So we have high energy particle physics, we have condensed matter and astrophysics in the room right now, which is pretty fun. I guess we're just missing nuclear physics. We need a nuclear physicist to join the stream, and then we'll close all our or check all our physics boxes. So yeah, thank you for joining us, Astro. It's always a pleasure. All right, the terrorists win.
But we are 3-2.
So is it tracking your statistics all night? Like, how are you doing?
That's a good question. Let me check. So I don't think it's tracking in general, but my score is 7. I am the best in my team, and I'm the best in general. So yes.
All right.
So I am better than an easy bot.
I like it. Cuddle Puppy, Huggy Beer. The word electron triggered me because it's one letter off of a different word. Assuming election. Sorry, Cuddle Puppy, I don't want to trigger you. We're all feeling that right now. We are smiling not to cry. Good time.
So, so this is a favorite physics fun fact when you are teaching about electricity. The word electron comes from a Greek word for amber. So they noticed that, of course, when you
electrostatics,
that's right. So when you take certain materials like amber, when you rub them on you, then you can become charged, right? You can be zapped, and the Greeks noticed this, and they called, and amber is called in Greek electron, and that phenomenon is coming from there. Yes.
Is it related or unrelated to election? I don't know about Latin roots on this one. Probably not related. Huggy Beer, I have smoke detectors in my house. Do I qualify as a nuclear physicist? It's worth a try. We'll give you honorary nuclear physicist status on this stream. But speaking of which, I mean, related to that note, have you heard of the Nuclear Boy Scout?
No.
This kid, I'll look it up actually. Nuclear Boy Scout. It was this kid in the 1970s. He was a Boy Scout, but he decided he wanted to try to build like a nuclear reactor or a nuclear bomb or something. And the way he did it was like collecting smoke detectors. Yeah. And ultimately there was, I don't remember the details, but at some point, like the Department of Justice or something showed up at his parents' house and raided the garage and like took all the nuclear materials. And the kid was banned from doing anything related to it. But yeah, there it is. David Hahn is the Nuclear Boy Scout.
He was very happy in the picture.
Yeah, conducted experiments in his backyard. He wanted to build a breeder reactor in his backyard. Han, Han's progress attracted the attention of local police when they found concerning materials in his vehicle during a stop for a separate matter. He warned them that it was radioactive. Yeah, the EPA was notified by this, and that's where they set up a cleanup site for it. So, yeah, interesting backstory. I don't remember the details beyond that. But yeah, check out the Nuclear Boy Scout and Huggy Beer aspirational goals. Oh man,
That's right, because the smoke smoke detectors, they have a nuclear material inside,
Yeah,
which is
it's,
decaying.
it's americium actually. Yeah,
And it's decaying by emitting alpha particles in addition to other things. And when you have when you and right and if smoke gets into the chamber, then this alpha particles begin ionizing it, and this forms a short circuit between two, like a positive and negative diode in your smoke detector, and that's how they know that there's a fire. So that is pretty cool that you are actually using
yeah.
a radioactive decay to do this. So
Yeah, that's pretty fun. Was he buried in a lead-lined coffin? No, he died very young. Let me look it up. Sorry, I got the Wikipedia page. Death, September 27th, 2016, at the age of 39. He died in his hometown. His death was ruled accidental result of intoxication and combined effects of alcohol, fentanyl, and diphenhydramine. So yeah, he OD'd with a blood alcohol concentration of 0.4 milligrams per deciliter. So yeah, he was high out of his mind. Because he was basically banned from pursuing this research, but I don't. Yeah, no, tragic, absolutely. I mean, it's one of those, like, under the right mentorship with the right parents in the right circumstance, this would have been a very different story. Because, man, to be that motivated to try to build that in your house is crazy. So yeah, interesting story. They should make a movie about it if they haven't already. Maybe they have. In popular culture, there's a CSI New York episode based on the character. Documentary called The Nuclear Boy Scout on Channel 4 in the UK. That's fun.
And there was also something with Big Bang Theory, which was motivated by this. Is that apparently the main character, Sheldon Cooper, kind of tried to build a nuclear reactor in his...
From americium from smoke detectors. Yeah, look at that. That's fun.
And but for example, Marie Curie, all of her and Peter Curie's notes are so radioactive, and so are their bodies, that when they are buried in France, they are buried in a lead coffin.
Yeah.
Even now, so.
Yeah, you have to get special permission to access anything. Yeah.
But for example, Peter Curie, he was walking with a chunk of radioactive material in his pocket just to show people. You know,
yeah. No, that was the Wild West. I remember when I first got here, it was like 2014. They had it was a one woman show recounting Marie Curie, but it went through what was it? I don't remember what they called them, but the women that were painting the dials on watches with radioactive material so you could glow in the dark.
Yes.
And they were they'd use their mouth to wet the tip of the paintbrush and then dip it in the radioactive material and do the swipe and then do it again. So they essentially spent 9 to 5 eating radioactive material. And it was, massively detrimental to them for obvious reasons. What did they call them? Somebody know off the top of their head?
I didn't know that. Let me go back to that.
Radium Girls. There it is. Thank you, Misadventures in Astro. Radium Girls. Man, the fatality rate had to be massive in that case. Searching for maps.
I am changing back to the maps that I know. I am not comfortable learning new maps.
Man, this is... Yeah, if you ever want to know why EPA and labor unions and all that stuff exists, this is one of those anecdotes, which is kind of crazy.
But so for example, now I think there are subtle watches that use thorium. I think.
Yeah, that's for the timekeeping, right?
Yes.
Yeah.
Well, not that also to glow in the dark.
Oh, interesting.
And there are goggles that you can use in your when you have a gun, for example, you can use radioactive materials also to have this glow without electricity needed. So.
Oh, interesting. I didn't know that. I like uranium glass, you use UV light. They don't have an intrinsic glow, but
that's right.
That is interesting.
So the UV, the uranium glass, you can buy subtle in shops sometimes, like when it's being sold and people don't notice that they're buying
uranium glass. It's pretty light. Uranium of the radioactive elements isn't that bad. Only when you have a critical mass and it goes critical. Man, that question, why would they ban it for life though, seems like a really smart and focused guy. Yeah, that's one of the... Can you focus it in the right direction? And if so, you have a scientist on your hands. Hopefully. Or a serial killer. I don't know. It could go either way. Maybe find some radioactive ore up in Saskatchewan. That's fun. I would love to find some uranium glass. We mostly just have radon gas here. Oh man, that's brutal. We laugh not to cry. Oh man. All right. So if you guys have any questions for Cyprian, throw those in chat. We'd be happy to answer those. We're talking about condensed matter physics while playing some Counter-Strike. Let me know at any point if you want to change games or if you want to play anything else.
I think this is good. I am finally getting my eye, hand, mouth coordination going, so I don't want to mess with this.
Yeah, I want everyone in the audience to appreciate the challenge of playing a game for the first time in 15 years, but also trying to do it at a level you used to play, like your brain knows what you want to do, but you can't execute the right way, and also trying to answer questions about these things. So, oh man, in case you were wondering, my basement is currently at 22, what is that, barquels per meter cubed radon. I don't know what scale is impactful in that case.
Is it bad or is it good?
Per meter cubed? I don't know, what is a Becquerel? Becquerel? Is that what it is?
Becquerel.
Becquerel, there we go. What's a safe range? I'm genuinely curious. I think we had an issue at FSU with one of the old buildings having some radon issues.
Oh.
I don't know, blindly following the LCD display. That is fair. Yeah, let's find the units on how radioactive is a banana. Oh, interesting. There's roughly 0.017 grams of potassium-40 in a typical human body, producing 4,400 decays per second, which is, yeah, the unit. That's interesting.
But you can check out what's the minimum amount of becquerels to do something.
Yeah, the LD50. Lethal dose. Becquerel.
So is this thing with the I think so. I learned that you can sometimes do this check. What is the amount of argon in your house, right? And then there's this way of fixing it that you put some kind of chute from the basement. I don't know. seemed.
It means you're doomed. No, it was 300 before I'd put a fan, had a fan put in. That's
So,
amazing.
this is what you do.
So yeah, you drop it by an order of magnitude if you install a fan. That is amazing. I just learned something new. And I'll have to look up the LD50. Are you good on drink or you need
Yes,
another one?
I am good, thank you.
There's one left.
Man.
Okay, let's go. Okay, let's go.
Yeah, I told everyone about this stream the day after the election. We were either drinking to celebrate or drinking in sadness. So hopefully everyone has their drink in hand for one of those two options. Cheers all that are joining us on a Wednesday night to play some Counter-Strike and talk about condensed matter physics. And then going down pathways talking about astrophysics, high energy particle physics, as well as nuclear Boy Scouts. So it's been a fun night so far. Man. All right. We should do another prediction. Let's pop another one up. Which one do you want?
So I like this one.
Alright.
Since we kind of.
Yeah, we did touch on Nobel Prizes, so let's...
But let me check. So I don't know if everyone knows what are the Ig Nobel prizes.
yeah.
So these Ig Nobel prizes are Nobel prizes that are, so they are not real Nobel prizes. They are prizes which are given for unusual scientific achievements. And very often they are some achievements that people laugh at. That, for example, you would use science to solve such a particular problem.
Yeah, one of the IG Nobel Prizes, if I remember correctly, is a guy for like 40 years only cracked the knuckles on one of his hands to show that it did not lead to arthritis. It's crazy things like that will get you the IG Nobel Prize. And then obviously you guys know about the real Nobel Prize, so...
Yeah.
Yeah, it's pretty crazy. But we're going to pop up a question related to this. Ask Scientist Gaming. We do predictions on science-related questions. The question is, has somebody won both a Nobel Prize and an IG Nobel Prize? Is there any person that has won both of those? So Nobel Prize is obviously the Alfred Nobel Foundation given out of Sweden for physics, chemistry, medicine, and physiology, peace, and which one am I missing? Physics, literature.
Yes.
And then there's an economics one that's in the honor of Alfred Nobel. And then you have the IG Nobel Prizes that's kind of started as a joke, but turned into a very popular thing. Sometimes it's sarcastic, sometimes it's real. Has anyone won both of those? So click that predict button depending on your degree of confidence. Bet your internet points accordingly. You can make us drink, hang out, whatever. Request a factoid depending on your success on the question.
So
Abydos, where are you guys streaming from? We are in Tallahassee. So I'm a professor at FSU, and most of my guests are professors at FSU. We've also had some program officers, had some guest visitors, but for the most part, it's going to be FSU-related faculty. So if you have a particular science in mind, go to the faculty website of whatever FSU department you're interested in and send me a name, because I'd be happy to invite them on the stream. Note that people say no regularly because the idea of playing video games and talking science, I mean, under the age of 40, success rates are high. Above the age of 40, it's hit or miss. But yeah, video games aren't for everyone, and talking while playing video games in front of an audience is a non-trivial ask. So, but yeah, we're streaming from Tallahassee. All right, you guys have about 15 seconds left. Anyone gonna bet Nobel Prize and IG Nobel Prize winner?
and I forgot to ask, and how did people vote for the snail?
I think it was pretty proportional both ways, but those that bet one way bet a lot, and so the payoff was pretty good. It was like 10 to 1 or something for the slower than a snail.
Okay, so
All right, Nobel Prize and IG Nobel Prize winner. Is there someone that's won both?
Yes.
The answer is yes. Congratulations on your payout. 2 to 1 payout. Old man Felonius on a roll. Congratulations.
Yes.
Who was it?
So it was Sir Andre Game and Sir Kostiano Bozello. So the same two people that won the Nobel Prize for graphene. actually won the IG Nobel Prize, and they won it for levitating a frog on top of a superconductor. They won the IG Nobel Prize, I think, in 2000. I want to say maybe 1 or 6. I think I have it in my cheat sheet. So in 2000, and then they got the Nobel Prize for physics in 2010. So 10 years difference. And
Sir Andre Geim, how do you
Geim.
pronounce Geim?
I think, yeah.
Yeah. 2000 IG Nobel Prize, 2010 Nobel Prize in Physics. That is amazing. If you ever wanted to levitate a frog, they showed you exactly how to do it.
And there's and because this was back before he was in Netherlands, and Kostian Novoselov was his postdoc, I think, if I remember right, and they had this nice approach to science that every week for, I think, couple of hours on Friday they would do most random things in the idea that they can learn something. and
Just free Fridays.
yeah,
whatever.
yes, and one of this was this idea: can you levitate a frog? But at the same time, I like to think that it's this mentality that you are challenging to do something new, that's how they led to graphene, right? Because what scientists would tell you, let me actually draw some, we take pencil, draw a bunch of, a layer of graphite on a piece of paper, and then you use a tape. So it was this nice refreshing take for science.
That's fun.
Yeah.
I do appreciate a certain recklessness and experimentation. With that said, so I don't know who did it first, if it was at the Mag Lab or was these guys that levitated the frog.
I think the guys at the Mag Lab, no, they were the first with a frog and a strawberry. But I think Maglab also did it, but only after it became, not something that people would maybe laugh at.
Yeah. It was one of them saw a video of it and they're like,
Yes.
we could do that too. The Mag Lab actually got in trouble for that. I don't know if you ever
Really?
heard that.
No.
Because that's an experimentation on a living vertebrate system.
Oh.
And so they didn't have IRB approval. And so, yeah, levitating a frog, it shouldn't do anything to the frog, but that's not necessarily known, right? Like, for all we know, we were causing hallucinations in the frog. And so, yeah, you have to get approval to experiment on living things and invertebrates in particular. So, yeah.
That's
I
interesting.
got reprimanded for floating a frog. And for those of you not familiar, I was actually talking to Stephen Hill about this like a week ago at the Academy of Science of Florida. And he was, those of you not familiar, like, we have a whole lot of electrons in our body. And if you apply a big enough magnetic field, we're something called diamagnetic. And basically we align our magnetic field to oppose the external magnetic field. And that's why something levitates. So,
That's right.
yeah, it's a fun physics problem, actually. Oh, man. All right. Yeah, if you guys have questions, throw them in chat. I'm going to leave you with a question as I run to the restroom. What's your favorite equation? And why?
Okay. So I think I really like the the quadratic formula, because you will find that many problems in physics, or at least the ones that I am attempting very often, the solution may be reduced to solving a quadratic formula. And I remember that that we all learn how to solve a linear equation very early on, maybe when we are like 10 or something like that, but how to solve a quadratic equation, that felt like a next level of scientific education. And then, of course, we moved to polynomial equations and so on, and that wasn't as big of a wow as this. But in terms of maybe what's the physics equation, then I think F equals ma always wins. You know, you can do a lot with that, with the Newton's second law. Yeah. Let me see if no one answered. I think we're good.
Sorry, I missed it. What was the equation?
So I had two. One was F equals ma, which is always good, and the other one was solutions of a quadratic equation. That is more. That is very useful.
That's awesome. F equals ma is a classic, an all-time classic. It's one of the things I love about physics. It's like we can shit on Newtonian physics all we want, but it works most of the time. Like most day-to-day life, Newtonian physics is just fine.
That's right.
Oh, man. I love taking a live. It kind of goes back to the nuclear Boy Scout story. Here's a researcher levitating live frogs for the lulz, and then went on to do world-changing work and win a Nobel Prize. Absolutely. Man. We should come up with an experiment that would win us an IG Nobel Prize.
That's right. Yeah.
What would it be?
There was one that I was fairly sure was going to win, but I don't think that won. It's researchers at MIT were trying to understand why when you break spaghetti it breaks into three pieces.
Oh, man.
And there's an actual paper in Proceedings of National Academy of Sciences, which actually goes through the physics and the map of it, and I thought that was a sure contender to the IG Nobel Prize, but they didn't win. Yeah.
So there's still time.
There's still time there.
Oh, man. That's like they've written papers on when you put like corded headphones in your pocket and it gets tangled. Like there's a, what do they call the nature of that problem? It's like a topological problem, right? Like
Because
why
you make a knot.
Yeah, it intertwines, and it's like even if you put it in there like uniformly wrapped up, it eventually tangles. And yeah, it's a fun physics problem.
The most on the nose IG Nobel Prize that I know was the one they gave to Volkswagen after the scandal with the engine turning into a climate friendly mode when they detected it was being so the Volkswagen, if I remember it right, somehow programmed their cars that they were able to tell that they are being measured for the amount of CO2 emission from the pipe.
Yeah, they got fined.
And the engine then turned into a mode which was meeting this, and the citation for the IG Nobel Prize was for the novel solution to a climate change problem. I think like that.
That's what I mean. Like sometimes it's satirical, right?
Yes.
Because I know they've given some for like homeopathy and stuff like that, right? Yeah.
So.
Oh, Lori, welcome to the stream. Thank you for joining us. What is our drink tonight? So I asked Cyprian what he wanted, and he said, let's keep it light. Let's do a hard seltzer. And I asked him what kind, and he said, what was your line?
The more random and weird sounding the name, the better it is.
So with that in mind, I went in the grocery store, and I found Zizzy hard seltzer is what we're drinking tonight. In particular, I'm doing the papaya passion fruit.
And I'm pineapple and mango.
It is pretty light.
Yes.
With that said, it's like somebody dissolved a Jolly Rancher in a carbonated soda. This is not my favorite hard seltzer I've ever had. Do you have strong opinions?
No, it's good.
It's getting the job done because I'm in my third one right now. So, yeah. We decided, Lori, tonight we are either celebrating or remorsing about the election yesterday, and so everyone's drinking tonight. Oh, Lori, the Zima of my generation. Oh yes, I remember Zima.
Zima
was ahead of its time. It was a hard seltzer before hard seltzers were a thing. And so they were early to the game, and then the last 5 years has taken over, right? It's been a crazy turn of events. But yeah, Lori, welcome back to the stream. Thank you for joining us. And what are we at? We're at 9:30. We should do one more of our predictions. Which one do you want to do?
Let's go for this one. This is a very fun fact that I like.
All right.
And this, I think, is good for a audience that uses Fahrenheit.
Yeah. And so just to give you guys some context, we're going to pop a question right now. You guys are going to click the predict button. This is going to be a science-related question, but most of the scales we use, I mean, they're somewhat arbitrary, right? Like a foot, a mile, a kilometer. Similarly, Celsius and Fahrenheit, they are somewhat arbitrary scales. And so we do some sort of bounding to describe something as 0 or something as 100. And so this question is related to that, in particular the scale of Fahrenheit. And so Fahrenheit, 100 F or 100 Fahrenheit is approximately body temperature, because Fahrenheit's wife was sick when he measured her temperature. Is that accurate?
Yes. So
is that true or false?
That's right, because we mostly so typically the reason why people come up with a new temperature scale is that you are trying to choose a most natural temperature scale for the problem you are interested in. And Fahrenheit noticed that 100 degrees Celsius is not that common in our life.
Yeah.
So Fahrenheit thought, okay, can I design a more natural temperature scale? And the idea was that 100 Fahrenheit, according to the urban legend, is that it is because of the body temperature, that it should be our body temperature, but for some reason, it's more than the normal body temperature.
It's at least 1 degree off, and is it because his wife was sick when he measured it? Schmonite, welcome back. Vizzy sounds bad, like back alley with a sharpened cart bad. Schmonite, do you want to know how bad it was? It was the girl that was checking us out, or checking me out when I was buying this, was like, "Oh, do you like this? I think they're terrible." But I committed anyway because it had a fun name. It met your criteria.
That's right.
Oh, you found a map.
I did.
Holy shit!
But I think I need to die for it to see it.
Oh, if anyone knows Counter-Strike and has a voice, that's amazing. Cool, man. Thelonious, I have insufficient amounts of alcohol on hand for the current events. I agree with you. We won't dive in it too much, but I do genuinely have concerns about scientific funding over the next several budget cycles, so we will see how things unfold. But I feel for you, old man. Cheers. We will drink together collectively in our sigh of exasperation. All right. All right, Cyprian, what's the answer? 100 degrees Fahrenheit body temp because Fahrenheit's wife was sick? True or false?
So the answer is it's false. It's not true.
False.
So Gabriel Fahrenheit, or sorry, Daniel Gabriel Fahrenheit. So he came up with this in the 18th century, and the urban legend, or actually, is that one that you can sometimes read, is that 0 temperature was chosen as the equal mixture of ice, salt, and water, and that's because that's the temperature where it melts. And people in Gdańsk, that's in Poland back now, but back then it was occupied by Germany, would put salt on the ice to melt it. So this is why Fahrenheit chose it as 0. And then the story is that he wanted to set 100 Fahrenheit as the body temperature, but his wife was sick at the time and he didn't know it, and that's how it stuck. So as far as I can tell, that's not what happened. Unfortunately, he chose the body temperature at 90, but apparently he messed up, and then this was corrected to 98.6. What he thought what was changed, and so this 100 unfortunately doesn't have any good origin.
0 meaning in the Fahrenheit scale.
Yeah.
In contrast to Celsius, which 0 is freezing of water and 100 is boiling of water.
That's right.
That makes perfect sense, but he didn't like the scale because we don't have 100 degree conditions. Yeah, the salt thing is interesting because salt usually freezes at 32 degrees, or sorry, H2O freezes at 32 degrees. But if you add enough salt, it has something called colligative properties. It's entropy driven. We won't get into details, but it's crazy you can get that down to zero. That is amazing how cold you can get water.
Yeah.
So what's happening now is tracking.
So I think those two guys are just looking at each other, the two bots, and I think the two bots don't know what to do. and they are just kind of stuck and waiting. So the only thing that I can do is I can change levels one more time.
So we're at 9:38.
So we should go to the...
Do you want to try one online?
We can try, but I'm just okay. I mean, we can try. So I can press find servers.
Just pick a server. So Cyprian's been playing against bots all night, and so bots are great, but humans that have been playing this game for 20 years, because that's the only people still playing this, are going to be something else, some other level. So I'm curious to see what actual online gameplay is.
So let me go with...
Be warned, protect your fragile ears, because Cyprian's about to be yelled at by a bunch of 8-year-olds.
That's right. So I can try to... Probably I am going to join, and then they're going to kick me out.
Maybe. We'll give it a try. Insta-death is absolutely right.
I don't know.
See some bunny hopping, cuddle puppy.
Oh, I think I am in some kind of loop. I don't know what's...
Oh, it's like an install loop?
Yes, I don't know.
Pass.
No, something is changing.
Go online so all the 6-year-olds camping out in the levels can headshot you in 4 seconds or less. Absolutely. And then have claimed to have sex with your mother. Yes. This is the online internet world we live in. But no better or worse than our political landscape right now. So cheers to that, ladies and gentlemen. Oh, here we go. We are back.
So I joined, and I think I am waiting for the round to end, and now...
Oh, wow. 3v3 is going to be high pressure.
Okay, so I have money, so... Or they already bought, and I'm like, okay, just what is happening? Where are my team members?
Are you feeling stressed right now?
I am very
high pressure.
Am I there? Oh, this is my friend. Okay, then why am I shooting with? Okay, that was cool.
You're gonna get yelled at so hard on this. At least it's a map, you know.
This is at least a map that I know. Yes, but
misadventures. We need multiplayer NARC. I agree. Somebody needs to make the mod. We'll close every Ask a Scientist night with multiplayer NARC. We will saunter around at incredible speeds until we shoot each other with rocket bombs, high-powered grenades, blah, blah, blah. I agree. I'm still waiting for one of you guys from chat to submit a speedrun time for NARC. There's a tutorial on YouTube that I created that tells you guys how to get in the top 10. So, yeah.
Okay, I'm dead.
God, they were on point. That was like 2 shots in the head. Holy cow. All right, should we switch over games?
Yes.
Or you want to try one more?
No, I think I am good.
All right.
So I will quit.
Here, I'll find it. Where's my speed run? So quit this guy and then go. Yeah, we're on the. They can't see. Yeah, so click that guy.
Oh, you want to do this? Okay.
Yeah, because we still have 45 minutes or so. If you're up for it, might as well. So yeah, leave that where it is on the screen because this will frame it up nicely for us as soon as it pops up.
Hopefully it pops up. It's frozen. Not responding.
We're gonna wait
it's
for
back.
It.
Okay.
We're gonna wait for it. All right. So what are we playing now, Cyprian? Give people some context.
So growing up, I was a very big fan of Dragon Ball. And there are these open source arcade games that you can essentially choose any Dragon Ball character and make them fight with any other Dragon Ball character, and I think that's pretty much it.
Yeah.
So
remember, it's like PO. Yeah.
I mean, we can try, but I'm not promising anything. I'm going to go single. and I'm going to go with
And so people have created each one of these characters, their animations, their...
that's right. So you have people here. So this is very impressive that there's someone who has, I guess, made animations for all of the different kind of anime characters, and then you can make them fight each other. I'm trying to. Oh, I figured out. No,
Team Arcade?
I don't want that. I think I messed up. I'm sorry. Arcade.
We don't know what
try.
buttons. We're using key
Okay.
bindings that we don't know. But Misadventures, if you're going to commit to NARC, here's the YouTube tutorial. That'll give you a time under 10 minutes and make you in the top 5 of NARC speedrunners in the world. Just follow the instructions, practice some jump. Oh, wow.
So that I am trying to fight with someone, and I think. So I am the guy on the left.
Getting obliterated. Yeah. So I played a little bit of this. I don't know the controls at all. I just do it to test if it works. I love how every move seems so epic and so aggressive.
That's right.
It's pretty spectacular. But yeah, there's a link if you guys want to learn how to play NARC. You can find emulators online, grab a mouse, a keyboard, whatever it is, play some NARC, beat a speedrun.
So what is NARC about? What is the theme of NARC?
We will get to it as soon as it's up. In fact, I have the game right here. We will read you the lore, the backstory.
Okay, so I actually managed to get a couple of kicks in.
So do you remember any of the combos or anything?
No.
Special moves?
No. And also this is a different version of this game. But I kind of okay. Okay. Oh no. See, I'm getting somewhere. Okay. No.
So 2 weeks ago we played some Tekken,
Okay.
which is the arcade version of the fighter, and yeah, that was pretty fun.
Yeah. So this is I think the same idea that there were versions of this game made for an arcade game, and then people like to play it on their own computer. So this is called Mugen. It's the name of the environment, and then there are different fan-made games. I think I either need to pause or I need to look the key binding. So we took this.
There you go.
I think I'm going to go firstly. I will pause, and I think I was too ambitious, and I will go back into the training mode where my enemy,
Practice a bit.
when my enemy doesn't do anything. Okay. So
Yeah, no, that's a non-trivial combat and off the bat. So can you just fight anyone, or is there like a level system, or how does this work?
I don't know. In my experience, you can fight anyone you want. So you see, this is one punch. This is a different punch. This is a kick. Okay. This is a key attack. So this is like kind of there. Okay.
Man. Sorry, our heads are in the way of some of this combat. Man, I can move us up. How about I do that?
No. This is good. This is okay. I think I'm getting this.
All right. Ready? There we go. Cyprian's going to float up here in the corner. And I'm going to float up here in this corner. There we go. All right. I just want people to see the gameplay, so I'm going to move it out of the corners, because that's apparently a place where you end up fighting a lot.
So, I think you see, I am, when my enemy is not doing anything, I am doing very well.
You're great at this game.
Okay, I can do that. Okay.
All right, Cyprian, while you get used to the controls again and start playing this game for the first time in a long time, one of my favorite questions that I like to ask, and it's because I've seen a whole lot of movies, is what movie or TV show gets your discipline right and what gets it wrong?
By discipline, you mean physics or condensed matter physics?
It could be either, loosely defined. So condensed matter could be everything from nanomachines and nanobots to, if we want broadly defined physics, just Newtonian or astrophysics wrong.
So I don't think that there's a show which particularly focuses on condensed matter, but in terms of theoretical physics research, what Big Bang Theory is doing is getting it very it's the same order of let's say type of research that you are doing. And in particular, there's one episode of Big Bang Theory where Sheldon Cooper is working on graphene. There's one episode like that. So that I think is very realistic. And in particular, there was a scientific consultant for Big Bang Theory who was ensuring that all of the physics that is discussed in the show is
It's legit.
it's legit. Now.
But on that front, I haven't watched the show. Does he strictly do condensed matter physics,
No.
or it's like astrophysics?
So he's the ultimate high energy theorist, which is string theory.
Okay.
Yeah. So there is no condensed matter theorist in any show, to my knowledge. Now, what I think my favorite types of physics representation in a show is that, for example, in Martian, the movie, there's this person who's doing orbital dynamics.
Yeah.
And
The character played by Donald Glover. Right?
okay,
Yeah.
and he was calculating about whether certain orbit is a viable trajectory. And the answer of that calculation is correct. This is what he gets on his display.
Yeah.
And in my experience, no one codes any code that you have that is going to output.
Correct.
Yes, calculation is correct. This is just not the case. Like typically, it's just a sequence of numbers or some output from a code, and you need to interpret this.
Yeah.
So that is the number one thing that many shows and movies get wrong, is that they assume that scientists or physicists make the effort of writing code to output an answer which is calculation right.
I would love to know what parameters would be defined as correct, right? Like you could do a single number. If you get this number, then correct will display. It's just simple if-then statement. But why would you write that for something like you're trying to find that number? And if you already have that number, why would you write that?
Oh yeah.
I completely missed that. I apologize. That is pretty amazing.
Yeah. So this was my.
That's your pet peeve.
That's right. Yes.
Calculation correct. Well, thank you, software. That seems like something ChatGPT would respond to you with, right? You are correct. Sure. Oh, man. I mean, so related on that note, the last time we hung out, we talked a bunch about science fiction books. I mean, are there books related that you've thought about?
Yes.
In terms of physics. What's your favorite?
So I think the book that I actually like all of the books by Andy Weir. They are very, very scientifically accurate. And in particular, I like the most recent one, the Project Hail the Mary. And I don't want to spoil it to anyone, but it's just for example, the very first chapter, for example, he is asking, how can I determine that I am in the uniformly accelerated frame of reference? And he is and the main character is kind of trying to reproduce some classic physics experiments. So that's a very good book. And then
So he's the author of The Martian.
That's right, the Martian.
And what the recent one that you mentioned?
The second one here on the screen, Project
Hail Mary.
Yeah, Hail Mary. That's a very good book. The Artemis I didn't like that much, but it was also a good premise. And then the other series of books that I like was the Expanse. So in particular, in many sci-fi movies, there's a question: how am I going to generate gravity on my ship?
Yeah.
and there's this mysterious gravity generator, gravitational field generator. Whereas in the X bars universe, it's this idea that also, I guess, motivated by Albert Einstein, is that if you are accelerating, you are it's indistinguishable from the force of gravity. So if your rocket is accelerating at the acceleration of g, the gravitational acceleration here on Earth, then it feels the same. So this idea in these books and in the series that you can have gravity because rockets are accelerating, then they turn and they are de-accelerating. So the rockets are built like a tower rather than layers.
Yeah.
It's very good. I think
That's pretty fun.
Yeah.
So that was the novel. Have you seen the TV series,
Yes,
The
yes.
Expanse? Did they do a good job? I've
think
never
so,
seen
yes,
it.
yeah.
You were happy with how they captured it in the TV show?
I was. The TV series finishes before the novels finish, which I think is it's a nice way that they didn't try to rush the show. They just left it maybe for someone to follow up at some point.
But you were happy with how they conveyed it?
Yes.
That's fun. Mildly related. Last time we chatted, we talked about Red Rising.
Yes.
So I finished the 6th book, actually. So I did all 6. You went to 3 and then bailed?
That's right, because I didn't like that they changed the writing from only focus on one character to more.
Yeah.
Yeah.
Yeah, if you guys aren't familiar, Red Rising, it's an 8-book series. I do the audiobooks and I listen to it while biking and driving, and it's like 20 hours per book for audiobook, but it's fun. It starts out like this class warfare and then evolves into intergalactic warfare, and I won't give any details beyond that, but it will be a 7-book series. There's 6 released and there's a 7th on the way. The 7th should be the final one according to what I've read. But yeah, the 3rd book, it goes from the lens of one character to several characters in book 3, which I found a relief at some point, because the first couple books is just him either, dominating people or him being naively caught off guard.
Yeah.
So, yeah, but that was kind of fun. The other one you suggested to me, I think it was Scythe, right? That was the one you mentioned?
Yes.
That's the one I'm listening to right now, actually. That's been pretty fun. That's like a young adult science fiction, kind of fun. Man, one that I've read or listened to between those two was called Longitude. Have you ever heard of this book? It's David Sobel, I think his name is. Yeah, there it is. The true story of the genius who solved Longitude. Sorry, there's an Amazon link if anyone's interested, but I didn't realize this was as big of a problem as it is, but this is a nonfiction book recounting the story of solving the problem of longitude. So latitude is easy, right? You can do this position of the North Star as well as the position of the star stay when you're on the equator, right? So you know your distance to the equator depending on how much the star moves. But longitude is an arbitrary line. And so you have to set an arbitrary line and know how far you are from that arbitrary line. And it turns out as a really hard problem, because essentially you need to keep time. You need to know the time at the origin, and if you know your time at your current position, you can figure out longitude. And it's this really epic tale. It includes like Newton and Galileo and Hooke, and ultimately the engineer that solved the problem, Harrison, with his different clocks. But it was such a cool story. It's like astrophysicists versus engineers versus other people, and it is a lot of fun. Anyway, sorry, shameless plug for a book that I recently listened to. I didn't realize how hard that problem was to solve, but it's part of this journey is like, the King of England offering millions of dollars for somebody to come up with a viable solution. And they basically set these DARPA-style metrics like, you need to be within 1 degree accuracy over a month-long period, and I will give you, 20,000 pounds, which is like $1 million today. And so they were this panel of longitudinal experts were the first granting agency, because people would submit proposals saying, I can solve this problem, give me money and I can fix it. And so the origin of our modern scientific funding mechanism is partially attributed to this. So, yeah. Sorry for taking over and spieling, but yeah. I'd recommend it. Anyone that's interested in just like science and scientific progress in general, check out the book Longitude. Yeah, one of the biggest scientific challenges of the early, it was the 1800s when this evolved. Yeah, sorry for hijacking the chat, but yeah, I'd recommend it. All right, man, we asked you about science. Oh, so it's 9:58. We'll say you're a pretty good gamer. We're gonna say 10:30. We'll probably switch to NARC.
Okay.
It'll take you 20 to 30 minutes to beat that game, depending on the jump rocket and how long that
I
takes.
think you are
Optimistic.
overestimating my ability.
I believe in you. I'm confident we got this. But yeah, before we do that, if you guys have any questions, throw them in chat. Cyprian's happy to answer any questions about 2D materials, about condensed matter physics in general, solid, soft versus hard materials, what it means to have those boundaries between them, physics in general. He is happy to answer any questions, or at least attempt to. And Misadventures has redeemed Take a Drink. So, Cyprian, cheers.
So I am finished with mine. So if I can
you
have
want
the
another one?
second one. Yes,
No,
please.
thank you for the reminder. Which one do you want? We have passion fruit. We have strawberry kiwi.
Can I have that one, please? Yes, please. Thank you.
Let's do it. All right,
Thank you.
there you go.
So it's funny that you mentioned. So that's something that I wanted to mention: the soft condensed matter physics. So in physics, probably the same in any other area of science, is that when you are typically you do research in the summer. That's like the more common in the UK. So I was desperately looking for a summer internship after my second year, and I couldn't kind of do any theory research because I lacked the necessary math background. So I managed to find one internship through the German DAD science exchange. And if I can summarize what it was primarily cutting raw spaghetti, that putting them in a container, moving this container up and down, 10 times, 100 times, 1,000 times, 10 to the 4 times, and then putting them through an X-ray nanotomography. You have then a three-dimensional image, and then you process that, and you ask how many times the spaghetti touch each other, and so on. So this was my very first research.
That's your IG Nobel Prize right there. You follow up on it.
Yeah.
Oh man.
So it turns out, from the way how I introduced it sounds a bit random, but it's a problem in soft condensed matter. There's something called the critical packing. So what is the density of objects of different shapes at which the objects jump, so that you cannot easily move them out of the configuration. And so, for example, the problem of cylinders is very common, or it's very technologically interesting, and we can encounter them every day when you are pouring, for example, coffee out of a container. If you pour it too fast and too much, it will jam in a hole, right? That's why you are pulling it slowly. So I was interested in cylinders with high aspect ratio, which turns out that the cheapest solution is spaghetti. But turns out, that then it was a matter what type of spaghetti. So turns out that cheap spaghetti, when I would chop it with a paper cutter, it would, at the end of it would divide into tiny strands.
Like prey.
So it's not what we want. So the brand that I can recommend for this experiment, it's Spaghetti Barilla number 4. And I think it's a safe bet that I'm one of the few people on earth that have put Spaghetti Barilla through an X-ray computed tomography. And I had run it, with my code, and it's called nanotomography because the precision of the image is it can be nanoscale.
Yeah.
So then I can say that the spaghetti barilla says that it's 1 millimeter in diameter, but it's actually 1.4, according to my sample of this. So yeah, so that was kind of a funny experiment to do, and then a big chunk of it was coding to analyze this data, you know.
Misadventures. My kid might study more if I tell him there's spaghetti science. That is amazing. You figured out the brand of spaghetti that did it best.
That's
Your
right.
grant dollars paid for that high quality spaghetti.
Yeah.
Man, that is amazing. I mean, it reminds me of, you see certain studies of like emergent phenomena, and I've seen like talks by people that just watch bubbles form, right? Like with soap bubbles, like packing of soap bubbles is an interesting problem because there's a certain amount of chaos and then packing density, and it's not something we can predict. And this goes back to your original statement, like, is this a tractable problem? Can we actually predict these behaviors? Can you predict the spaghetti behavior?
So here this was the question: what determines the packing density, and I think it was the number of contacts that the spaghetti makes, and there was some kind of law. I don't remember it anymore. It was as a early undergraduate, you are in and you desperately want to get something done, and you're like, it's at the level as I don't know why I'm doing it, but it's not a problem. I will be chopping the spaghetti if you tell me to do it.
I will chop so much spaghetti. What did you say, 10 to the fourth?
Yeah.
Oh, exactly. But those are the experience that shaped us. Like, yeah, I did an RU where I was doing shake and bake chemistry and crystals came. And I get it. I fully get it.
Yeah.
Man, one of my favorite examples of that is there's the, I don't know if you've heard of the terminology emergent phenomena,
Yes.
right? Where you just have, greater than the sum of its parts, something new
Yes.
emerges. It turns out one of the foundational things that's not necessarily understood is icicle formation.
Okay.
Because icicles have certain like patterns and ridges associated with them. They're not just linear formations, but they have like distances between the ribbing on the icicles. And it is not understood what factors dictate that. And so like they've done studies where they take a camera on these icicles as they form, they change salt concentration, they change water evaporation, they change temperature, and they don't know what dictates these pattern formations. And so people are out there trying to figure it out, but there is not an answer right now. So somebody has grant dollars to film icicle formation and try to model that behavior. Oh, look at that. You're tearing it up.
That's right. So I am building up. I think he's gonna die and KO.
Nice. So this is coming back?
A little bit. I think it's a matter. So the point with this game is that you need to be the very first person to hit, and then you don't sit up until you see until the person.
Some multi-hit.
Spun, and then you are kind of building up your key, which is this orange bar at the top, and then when it gets to be full, I can use my
your
ultimate.
special. Yeah.
Yes. So this is.
So is there a progression here? Are you moving up in
I
levels?
have no idea. I can imagine that there is, but I kind of.
Yeah. You kind of sent me a link to one that you found, and it
That's
worked.
right.
So let's do it.
And to be honest, this is a new thing that I can actually fight and win. So give me a moment. Okay. So let me. Okay. So you see, I'm loading up, and now I can do my ultimate. There you go.
There we go.
What was my ultimate? It's just this? That doesn't sound real. Wow. What's happening? Whoa. Oh, okay. You see, that's a good animation.
It's totally worth it. Oh, look at that. Oh, that was enough. Wow. Speaking of science fiction, holy crap. That's a lot of energy to localize in that particular space.
Yeah.
All right. We did not cheers to Misadventures request.
Oh,
so
sorry.
cheers, Cyprian. Cheers, Misadventure. Hopefully have a drink in hand, hanging out on a Wednesday night, playing a little bit of Dragon Ball What is it? What's the name of this one in particular?
So this is Jump Force.
Jump Force, Dragon Ball Jump Force. Apparently, there's open source ways to make these, and people have done all sorts of different characters, moves, and whatnot. Yeah, so we were playing one of those tonight.
So was it Dragon Ball big in the US? Or?
I missed the Dragon Ball wave. I remember it like
Uh-huh.
it was post Pokemon. Dragon Ball took off quite a bit. A lot of cartoons, plus there's a card game, right? There's like a turn-based game. I don't remember the fighters. I don't know if those were big. Anyone younger than me might have some insights in chat, but I do distinctly remember a Dragon Ball phase in the United States.
I remember Dragon Ball that it was. I think it's true with any manga that you read it backwards because it's Japanese.
Yep.
Yes, yes.
Yeah. Yep.
And my-
Yeah. There's a substantial manga collection at most of the libraries. So I don't know if you've looked at any of the public libraries. There's an audience. All right, should we do another prediction?
Sure. So we can do the one with Einstein.
Wow. Continuing our Nobel Prize theme. If you guys aren't following us, click the follow button. You'll get 300 standard internet units to spend on our science-related questions. We're going to post a question for you guys to answer, and then our expert guest is going to expand upon the answer of those, because they're the ones that came up with the questions. So we like to ask you guys questions, and you can use your standard internet units and maybe make us take a drink, maybe request a factoid, unlock a emote, whatever it might be, while Cyprian beats up on some people in Dragon Ball. So we're going to put up a prediction right now. Einstein's Nobel Prize was for relativity. True or false? Was he awarded for his contributions to describing relativity? There's not much to add on that.
No,
That's the pretty straightforward on this one. Was his Nobel Prize for relativity? He did get a Nobel Prize, we will admit that much, but what was the Nobel Prize for? Is the answer relativity?
So I was going to. So this is a common joke when someone mentions imaginary points. So you probably know this T-shirt. Imaginary numbers, but the fun is real. So
Classic.
Yeah. So
Do you own that shirt?
I also.
You have a healthy collection of shirts. 'Cause if you saw the PowerPoint slide, did you look at it? I don't remember
Yes,
what it
yes,
was.
yes,
What was
yes.
the shirt you had on?
It is not. This is not the drill. Yes.
Yeah, it was like a hammer. I didn't
Yes,
see it.
that's
This is not a drill. That's amazing. Is that one of your hobbies? Science-related shirts?
So on Saturday we have an outreach event in the physics dev department called Saturday Morning Physics, where we introduce a particular topic to a general audience.
Yeah.
And this Saturday we are doing one with the Society of Physics students. So it's the undergraduate students who are actually running the whole thing. So it's going to be fun. But our topic is classical physics, and
That's
it's Newton's laws and so on. So I have a T-shirt for that. So it's planned, and the T-shirt is that it's a heel and a ball on top of the heel, and it says underneath, "I have potential."
Is that this Saturday?
Yes,
That's coming up. What's it called?
It's called
Is there webs-
it's Saturday Morning Physics. So if you type Saturday Morning Physics, physics, FSU, then what you would come. So the internet age group is middle school.
Saturday Morning Physics, Florida State University. So it's on this webpage.
Yes.
Oh man, if you guys are interested, check out Saturday Morning Physics. Where is this located? On FSU campus?
That's right. It's in the on FSU campus in the
And
physics building.
This upcoming Saturday, what is that date? That is November 9th.
Yes. So
Classic Newtonian physics. Cyprian will be there. He'll have his T-shirt on. He has potential. That's pretty awesome.
and then I found a T-shirt where the ball is on the bottom of the heel, and it said, "I had potential."
They should have that on the back. That is amazing.
Yeah.
Oh, we got a raid. Look at that. Actual Education rating with a party of 13. Thank you for joining us, Actual Education. I hope your stream went well. I'll have to look up. What are you guys up to? What were you doing? Actual Education. Here is a link right there in chat if you guys want to check it out. Education-related streamer. Non-profit reward, students for learning math and science. Join the Discord for help in classes. Find out how you can earn cool prizes. Presumably this is tutoring-related things. That's awesome. They do office hours if you guys want to get some help on various topics. What is your expertise in this particular math and science? So yeah, if you have questions for actual education, that is awesome. Math and science streaming. Saw we had a physics con. Absolutely, we have a condensed matter physicist on. Cyprian Lewandowski is happy to answer any questions. Taco, thank you for the first time chat. Thank you for joining us. If you guys aren't following, click the follow button. We only stream every 2 weeks or so, but we always have a science guest on of various expertise playing different types of games. Oh, that's fun. Actual Education has a PhD in plasma physics from UCLA. That's awesome.
Yeah.
Plasma physics. So
Does
does that fall under the umbrella of high energy? Or
no, this is actually a branch on its own. It's just less common in the US. I think that most people who do plasma physics would be in astrophysics, but there's a bunch of people who do plasma physics because of nuclear fusion.
I see.
It's just part of the thing is that the nuclear fusion as a research direction, I think, is a bit less funded now in the US. And US, I think, may have only one tokamak in Princeton, I think, but there's definitely more focus on nuclear fusion in the EU.
Oh, that's interesting. So Actual Education says we have our own APS meeting. They did work on turbulence for fusion, and there's a lot of private funding.
That's right.
So fusion got a bad rap, right? Because the Utah team that completely bastardized their results, right? But now it's coming back.
Yeah.
Man, that is fun. A lot of private funding now. I mean, if you get it to work, right? That's one of the holy grails of energy research.
That's right. So there's a lot of startups that actually get that they have their own private, they have own unique design and they get some seed funding and
Peter Thiel, yeah. In terms of private funding. Everybody's trying to become the next Iron Man. How do you feel about Iron Man physics? So yeah, Actual Education, one of our classic questions is movies or TV shows that get your discipline right and wrong.
I mean, I think at the early on it's kind of believable up to a point, and then it goes off the tangent. But but it's okay. What I like is that sci-fi or a fantasy can be as random. Sorry, can be as arbitrary as you want it to be, provided that it has consistent set of rules.
Yeah.
Like one of the common criticisms is why J.K. Rowling's universe is not that good. Because
it's inconsistent.
It's because there's nothing which is limiting the power of the spell. It's just it's a little bit arbitrary, right?
Oh yeah, I've seen that critique. Because like, you have time travel in movie 4 and never use it again. What the fuck? That should be your number one priority in solving any problem is time travel. But anyway, we have an exchange here. Still the Canadian. Hit it with the huge hammer reactor. That's fun. The Iron Man arc reactor is basically a tokamak.
Yes.
What is that? What's a tokamak?
So a tokamak, and I'm sorry if that's going to be a wrong answer. So maybe we should listen to Actual Education. But it's this idea that you have a magnetic field that is generated, and there's an ionized gas of electrons that is running around, and it's being heated up until nuclear fusion begins. So tokamak is essentially a donut, and
That's awesome. You're good. It's a Russian donut. Said we're going to define it as Russian. And then there's Spider-Man with Doc Ock, and his laser contraption is basically NIF, National Ignition Facility.
Huh.
So what is that, Spider-Man 2 with Tobey Maguire, where they had the reactor, the fusion reactor?
Oh.
Is that what? I apologize, I'm not up to date on my Spider-Man. 192 lasers pointing at a target.
Oh, yes.
Bad. I love that the answer is ultimately point enough lasers at a single point, good things will happen.
Heat it up, yeah.
That is amazing. Oh man, nobody picked anything on Einstein's Nobel Prize. So Nobel Prize for relativity, the answer is...
It's false.
It's false.
It's for the photoelectric effect, but arguably that's not what he's most famous for, right? But so in 1905, Albert Einstein has what we call annus mirabilis. So he wrote 3 papers which ultimately revolutionized, he wrote 4 papers which revolutionized each of the branches of physics. One is the special relativity, photoelectric effect, the Brownian motion, and I'm blanking on the 4th one. Sorry. And so the photoelectric effect is a crucial experiment so it was a theory which explained the experiment that proved that actually light is built from particles, light can be both a particle and a wave. So it is to me amusing that we associate Albert Einstein primarily with general relativity and special relativity, but not with photoelectric effect, which in many ways has initiated the field of quantum physics. And maybe can you search Albert Einstein annus mirabilis? Because I think he wrote 4 papers. And I forgot the
What is it? What's the...
It's, I think, annus mirabilis. Annus, no, sorry. In Latin, annus.
Okay.
So he wrote. Sorry, and did we go? Which form? Yes. Oh, sorry. And the other one, of course, E equals to mc squared. This is the 4 papers that he wrote in 1905.
So special relativity, light quanta,
Yeah.
Brownian motion, and E equals mc squared. He also hypothesized the laser existence, right? Like early, he was... Yeah, the probability of transitions. Like his early stuff was, yeah. Man. How many Nobel Prizes do you think he should have got?
That's right. So he won only one.
Photoelectric, which is key to quantum.
That's right, but it's not what he's most famous.
Well, I mean, the hard part is relativity wasn't confirmed till what, 60 years later.
So depending who you ask, right? The experiment which is believed or which is argued to be a confirmation of general relativity is the one by Sir Arthur Eddington in 1919, which measured deflection of light around the sun.
Yeah.
But apparently people have revisited that data and they said that Arthur Eddington, that's an article on Wikipedia if I'm remembering right, he actually he said that you can see it in his data, but you couldn't see it in his data. But Arthur Eddington was just so convinced that it must be there that he made everyone believe Albert Einstein. Then the actual measurement, which was unambiguous, was I think 60 years later in the next sun eclipse. Yeah.
So is it a scenario where he believed it so much that he fudged the data, or he believed it so much that his interpretation agreed?
I think he helped interpret the data in a way that it worked. But I hope that I am not upsetting anyone who's a Sir Arthur Eddington believer.
Yeah. But now everyone's GPS works because we correct for relativity. So cheers to that, ladies and gentlemen. We're glad relativity.
That's right. So yeah. So this is the everyday experience of relativity.
Yeah. And it took like 90 years to realize the first example of applied relativity. No, I guess that it was before that people knew it was important.
Yes.
I mean, but nuclear physics. Yeah.
But the GPS idea is it's in my simple way, and that's the way how theorists think, that we make a very simple. It's essentially a bunch of satellites, and they keep saying the same code 1, 2, 3, 4, 5, 6, let's say. And by measuring the delay between different 1, 2, 3, 4, 5, 6, that you can measure how far you are from different satellites.
Yeah.
And if you were not to correct for the time dilation, which is what general relativity tells us, you would have some error which accumulates, and it would be a...
What's amazing is the mechanism you described is exactly the conclusion of that longitude book. Like, that's how they solved it. Can you count? And if you can count, then you can tell position, which is absolutely amazing. Man, that's fun. So relativity might have been a hard sell. Brownian motion seems like it should have gotten a Nobel Prize, right? Like, that's foundational to most, statistical mechanics and thermodynamics.
Yeah, so that was, I think, his PhD thesis was Brownian motion. He came up with a novel method of measuring Avogadro's number. This was
Man, so are you feeling better about your fighting now?
I think so. I won one more time. So I think I got the gist. So the gist is that you attack first.
Yeah.
And if you attack first, you see they don't have time to answer. You just build up your...
Yeah, just freeze them and go to town on them.
Ultimate.
So did you did Dragon Ball comics or cartoon or anything?
Comics
You were into the
first,
comics?
And then they also had a cartoon in Poland, but I didn't manage to catch all of them. And the comics I had all 20. So there were 46 comics in Poland. 45 comics, and I was missing, I think, 6 out of the whole. Oh, please don't mention
No,
movie.
we're not going to do it. You've seen it though?
Yes.
Oh, man. This is one of the. I think it's cited as one of the worst comic book adaptations to movies. If you guys haven't seen it, Dragon Ball movie. Oh man, people hated it so much. 1, they whitewashed it, and 2, it was just not good. Right?
Yeah, it was very bad.
I think we're due for a good Dragon Ball movie.
I don't know if people are
People were
interested in Dragon Ball.
No, that's true. It might have passed, but like One Piece, they did good on Netflix, right? That one's been pretty popular.
One Piece?
Yeah, the adaptation, the comic book One Piece.
I don't know that.
Oh, man. Sorry, I brought up the movie. Oh.
Aragon is a different movie that they butchered the books. I was very disappointed with that.
Yeah. What's your worst? You've read a bunch of sci-fi. What's your least favorite adaptation of a sci-fi book?
So sci-fi?
Yeah. I was tempted to watch the original 1980s Doom adaptation. The other night, that came up on the screen. I was like, should I watch Doom? Yeah.
I don't, with the sci-fi, I don't think I am particularly disappointed with any.
Yeah.
Oh no.
Sci-fi, does World War Z, does that count as sci-fi? Zombie invasion, are you familiar with this one?
Yes.
Because I was really unhappy with the movie adaptation. Because it was like, the book was looking at how the world would respond to a zombie invasion, and it was like very, social and political and like how different countries might perceive that experience. And then you go to the movie and it's just like Brad Pitt and zombies. So I was pretty disappointed by that. But anyway, one example of it. Oh, man. All right. So we're coming up on 9:30-ish. So our fastest NARC time is 17 minutes. Our slowest NARC time is 38 minutes. Where do you think you're going to fall on that spectrum?
Probably normal distribution.
You're going to say somewhere in the middle?
Yeah.
Before we do that, Lori has requested a factoid.
Okay.
Drop a knowledge bomb on the audience while you beat up on some... I don't know what that character's name is. Go on.
So I need to choose something. So
Just drop a knowledge bomb.
Let me go. There's a very famous saying by Hilbert, which is an incredibly famous physicist and mathematician, and he said that physics is too hard for physicists. This was a diss on physicists not being able to do math.
So he's saying mathematicians are the exclusive holders of the math, and physicists can't do it.
Yeah.
Do you have that on a t-shirt?
That I don't. Yeah.
Hilbert talking shit to fellow physicists.
Yeah.
That not... Oh, man. That's fun. So Hilbert said physics is too hard for physicists.
Yeah.
Do you think that's true?
I think sometimes. Sometimes we do need insights from the math.
I mean, but what's hard is that your likelihood of being an expert at mathematics and experimental physics is not... it's hard, right?
That's right. But also this idea that you might encounter a concept in physics, which you see in a lab, you measure, but you have no idea how to explain it because no math that you know captures it. And then it's too hard.
Yeah.
And you need help from.
Then you have to make new math. I mean, that's the one. So I'm a bit of a mutt in the chemistry world because I could be classified as materials, inorganic, physical, organic in some respects. But the thing that separates me from physical chemists is I will never generate a new model to describe anything, right?
Okay.
I'll use known models to describe electron transfer, energy transfer rates, and things like that. But nonetheless, I mostly publish in physical chemistry journals, but I'm not a math person. So physical chemistry is too hard for the physical chemists is what I would say on my front.
Yeah.
But you are on the math end. I mean, you're the programmer, you're the mathematician, you actually derive equations.
That's right. I am more on the math end, but I also know that the math end is long. So I am not on the far end of the math end of the physics. I am more applied.
But I mean, of the students you get, I mean, you're relatively new to the mentorship game, but they're not trained in math necessarily, right? They're not mathematicians. They don't have computer programming experience.
That's right.
Where do you start with your students then?
That's a good question. So a big challenge is that most of the problems in theoretical physics, unlike the problem sets which we give to students, you can't solve using pen and paper. You will need to code something up, even just to, for example, make a plot or just to solve something. So a big challenge is to come up with a toy model or a toy problem that the student can attack and then be able to solve it numerically, and very often there's a steep curve of learning that the student is learning how to code something up.
So this is a unique scenario where you could literally code in correct.
That's right.
You could do it for your students.
Right.
Like if they got the right answer and you know what the answer is. Sorry, if you weren't here earlier, we talked about it was The Martian where he had he put in some numbers and the response was correct.
Calculate correct.
So you could do that for your students. They would feel great if that popped up on the screen, but it would give them an artificial sense of what programming is, because you do not get it just to pop up correct. If it gives you a numerical answer of some kind, you have to be excited, right? The code at least worked at the very least.
And very often, the code doesn't work on first attempt. And what I learned this work for how we debug the code, right?
Yeah.
Is that one way is that we are trying to reduce the code to the minimal part of code which will have the same error. That's of course the better way of solving it, but the other one is what my friend calls stochastic debugging, meaning that we change random parts of the code until it works.
It's just pure attrition debugging. That is amazing. All right, Cyprian, this is probably the last one. Are you ready to move on to the NARC?
I am ready. I think I am going to lose, but that's okay.
We have nothing to prove here. We're hanging out, having fun, talking some physics. If you guys have questions for Cyprian about condensed matter physics, two-dimensional materials, atomically thin materials, stacking atomically thin materials, and getting unique properties, he is happy to answer those questions. While we close out, playing some Dragon Ball fighting. This is, what was it, Jump Force is the name of this one?
That's right.
It's open source. If you guys want to like download this, you can play this right now. It's kind of fun. The key bindings are a little bit weird, but you figured them out.
That's right, you do.
Got used to them pretty quick. But yeah, if you guys want to play that, we're going to move on to some NARC, and Cyprian is going to race all his colleagues across Florida State University and beyond and see how good he is at winning the war on drugs.
I think I won.
The special move is so
That's
epic
right.
in this. Like,
That's
it feels satisfying, right?
Yes. Okay, and on that I can finish.
No, you took a win.
Yes.
All right, so we're going to transition. We're going to switch over computers right now. I apologize if this crashes. We've had OBS crash multiple times when switching monitors, but we are going to do our best as we switch over to the Nintendo Entertainment System. Come on, screen. All right, look at that. All right, ladies and gentlemen, we are switching over to NARC. Before you start going, you need to learn a little bit about the lore. So here I have my original NES cartridge. I found this at basically a pawn shop selling old Nintendo games, but you're going to learn the lore behind NARC. Are you ready? You are Max Force. Your mission: bust Mr. Big, destroy his dreaded criminal empire, seize all contraband, stolen money, illegal weapons, use rocket bombs, high-powered machine guns, apprehend all suspects, protect the innocent, and punish the guilty. Stop at nothing. And the tagline is, no one had the guts until now. Are you ready for this? So do you want to see the clock or do you not want to see the clock? It's totally up to you.
Let me not see the clock and then be shocked at the end.
All right, I'll move the clock to the side. You guys can see it. Cyprian cannot. Press start. As soon as you hit the ground, yes. As soon as you hit the ground, I am going to press the clock.
And start.
All right, your goal is to go right as fast as you can. There's no advantage in killing anyone other than them shooting you slows you down a bit. Tapping A gives you a rocket, holding A gives you bullets, tapping B gives you a jump, holding B gives you a squat, and you want to find doors, go through doors, go right, do it over and over again as fast as you possibly can.
And how do I run, or there's no...
No, there's no run. You have one speed, and it is a casual saunter. That's what we're going to describe that as. Old man Felinius wants to know, from something you said earlier, 2D materials are high energy particles at high energy physics at low energy. That's one of the most fascinating things about condensed matter systems. Can you talk about it more? Why do you frame it in that high energy physics at low energy?
So it's this idea, it's maybe mathematical in nature, that you are... Okay.
There you go, then through the door.
It's you... Oh. Okay.
You're good.
You are asking what equation describes their motion. And in low energy physics, we notice from Newtonian mechanics that most particles move like their kinetic energy is 1/2 mv squared, or p squared over 2m if you're talking in terms of momentum. And now for graphene, for example, if you ask what equation describes properties of electrons in graphene, their dispersion is, so the energy is E equals to P times V. So that's why what I would call it's linearly dispersing. And then if you think about Albert Einstein, who we discussed today. Albert Einstein said that every massive particle, so every particle with a mass, must follow E equals mc squared, except photon, which is linear in.
So sorry to interrupt the explanation. You got to shoot these guys wearing black with bullets. So holding A, rockets won't do it. You have to hold A to do bullets.
Okay.
And one of them is going to drop a blue card. That one, grab it, go through the door. All right, sorry, keep going. Einstein, yeah.
Yeah. So and how do I insert? I jump.
You picked up the card, right?
I
touch it, move around there. Its hitbox is weird. You touch that thing.
Right. I like. This is the main difference. So then if you're asking about certain phenomena which we have in high energy physics, for example in quantum electrodynamics, the particles there can also be thought as linearly. These, when they are moving fast, the mass might not be important, and then you actually end up with the same mathematical equation which describes properties of electrons in graphene as it is for electrons in high energy physics. And so this is kind of the analogy that I was mentioning, and yes, and there are different phenomena and that's an area of research that people think of phenomena in high energy physics, and then they
jump in that car.
Jump.
Yep. So tap B. There you go. Tap B. Tap B. A little lighter. Go right. Stay on the bottom. You're gonna run into the bombs, but that's okay. Laurie, classic NARC drink and drive. So cheers. Your drink's still good.
Cheers.
Yes. Go right. Laurie, cheers. Hopefully have a drink in hand, hanging out. Dealing with the drama of graduate student rotations and choosing groups and things like that. Laurie's our graduate student advisor in chemistry, and yeah, we do our rotations and decisions in November.
That's interesting. So you do rotations.
So tap and jump, yep. So right away,
chemistry.
Students do rotations, and they have a couple. NCERM, this the central regional ACS meeting, recruiting students. Yeah, 1 week from now, Laurie, we got the Q&A stream on Twitch, so that should be fun. We do a recruiting, I'll mention this at the end, but we do a recruiting Q&A, and I'm the guest, and Eugene DePrince serves as the host, and I'm the chair of the admissions committee. And so we just invite any prospective student to come on chat, which is kind of fun. Oh, Laurie's in Pittsburgh right now. That's awesome. I forgot the timeline of regional meetings. So Laurie, hopefully that's going well. Give some shout outs to Twitch. We're gonna have some guests next Wednesday night when we do the actual stream. Oh, sorry to interrupt, but yeah, cheers to everyone. Hopefully have a drink in hand. Laurie, thank you as always for joining us. It is a pleasure. How are you feeling about NARC right now?
Good.
Whole lot of walk, right?
So far it's like this game where you are in a car and you try to avoid
So jump in that car, stay on the bottom of the screen.
But why on the...
Oh, no, that's why. Now you're walking, sauntering at a healthy pace. You'll get one more car at the end, but yeah, it's just going to cost you a little time.
Are you sure that if I jump, I am not getting better?
No, it's just walking. Yep, there's no speed advantage. You lose time if you go up and down. As you can see, as forward as x-axis pace slows down. I know way too much about this game, and you're going to learn as we progress. All right, but if you guys have questions for Cyprian, if you want to distract him from his speed run, he's competing against colleagues across all of the Florida State University, including your colleagues in the Department of Physics. So I've had David Collins, Maya Murphy, Rachel Yohei, Ted Kohlberg. I think that's my physics set so far. Hanwei Gao.
And you also had Hitesh.
Oh, I did have Hitesh.
So,
yeah.
Hitesh is in the same area of physics as me. Yes.
Yeah. Did he warn you about the stream?
No.
Do you want to know his time?
Afterwards.
You don't want that pressure. Speedwalk at best is a correct descriptor. NARC jumping does not conserve forward momentum. New physics. No, jumping does. As long as you're moving forward, jumping does. But if you press up or down, you lose all momentum. You slow down quite a bit. Okay, so stay on the bottom after you get in the car. So tap B, stay on the bottom. This will take you all the way to the end of the level. Congratulations, a new level beat. And old man Felonius. You touch on something very important, and one of the reasons I really love speedrunning in video games. If you're familiar with the speedrunning, is just beat games as fast as you can, right? And the way you beat games is go through it. It's a weird hitbox. The way you beat games as fast as you can for like any speedrunning community is you have to understand the rules of that game. And so foundational to speedrunning is scientific method. You say, here's what I think the rules are. If I try X, then Y will occur.
Yes.
And so it's just this really awesome systematic testable hypothesis. And it's not the general rules of physics that we adopt in our day-to-day lives, but it's the rules that govern these games and their behaviors. And so I really love it from that like scientific method standpoint. So you're going to go all the way to the right. You'll find a door at the end. Here's the clowns. Murder clowns, absolutely. Old man, is this your first time seeing NARC? Because this game is spectacular. All right, go right. You're going to find a white card. And then there's going to be a door at the end of this level, and you're going to want to go through the door, but don't press up too much or you'll go through the door again on the outside. So go up, but not too much.
Boring. I'm just being beat.
Oh, there it is. So now you do it again, but don't go through the door a second time. Old man, this is going to inspire you to pick up a Nintendo controller, the crippler, the ergonomic failure that is the Nintendo controller, and play some NARC. Go left. See that silver card slot? You're going to put it in there. Card slot first, and go through the door. Next level. But yeah, this is one of our all-time classics. We have at least 2 emotes dedicated to NARC, because I make every single guest play this at the end of the night, and they are playing for the first time ever. Oh man, we did not know how bad this controller is. Are you feeling this in your hand?
Yes, I can feel it in my
ergonomics hand. Be damned, you're playing some Nintendo. All right, go through the door. You're going to go left on this one. What you're going to do is want to shoot this Rambo guy at close range with bullets. So go left, and eventually he's going to drop a green card. So maybe move up a little bit. Oh, that's a marijuana plant that blew up. So move up, because you can't get it on the bottom of the screen for some reason. You got to shoot him with bullets and not rockets. The NES controller taught us that maybe things were meant to be held steadily should not be sharp. I agree. No,
I got some card.
Was it green? Sorry, I missed it.
No, it was silver.
So yeah, so they're like dropping money and bombs. So shoot that guy. Turn around. So you don't want to shoot him too far away because he won't drop a card. This is just stupid Nintendo rules again, the physics. So you have like a 1 in 4, there it is, green card. So you have like a 1 in 4 chance of him dropping a green card at a certain distance. This is Nintendo for you.
But people don't know these rules up front. Right?
Oh no, absolutely.
They figure it out later.
And this is one of those like why Nintendo games were horrible without the internet, right? Because you never knew the secret passage, you never knew the rule that dictated anything. But now we have the internet. You can watch YouTube videos and tutorials and figure out things. But yeah, if you guys want to distract Cyprian, he's on a solid pace right now playing through some NARC. But if you want to ask him questions about condensed matter, solid state physics, physics in general, he's happy to answer them. I mean, what's crazy is like you might say like I'm limited to condensed matter physics, but of a general audience of people that you come across, you know more astrophysics than anyone, right? You know more high energy particle physics.
That's right, because that is the part of the physics education, because you find very often that there aren't that many new ideas in physics, but the same, maybe that's too harsh. What I am trying to say is that many ideas find realization in different branches of physics. So I think very often this is the normal way of teaching physics, with this idea that you might learn something in one setting and then it's kind of applicable to your new problem, because that's how we normally grow knowledge, right? We bubble from something that we know. So yeah, but it's also interesting, the course that I am teaching now, so this is for non-physicists that need to take essentially modern physics, and it's an interesting course because you can't assume the necessary mathematical knowledge that you would expect in a physics undergraduate. So very often the physical concepts and the way how we set up problems, they need to be conceptual in nature. In a way, I think that's the way how physics is meant to be thought of, is that you eliminate the math out of the discussion and just focus on the like key ideas like conservation of energy.
Yeah. I mean, is that how you think about a big problem you come across?
I think this is the way how I should think as a problem, and that's what I always strive. But at the same time, knowing the math, it kind of helps you rephrase the problem more easily in terms of something that you can solve.
I see. So you found a utility in both modes of thinking,
Yeah.
mathematically as well as, yeah. And that's fun. I mean, one of my goals with general chemistry is to show that the math is not a boogeyman. I don't like plug and chug, but I also, don't want them to abandon equations. So here what you're going to do is kill the things on screen. I would recommend using rockets, because what's going to happen is a guy in a wheelchair is going to show up, and you're going to have to shoot him 3 times with rockets. And so stand, somewhere in this middle range. Fire. There you go. That's 1. So you're going to have to do him 3 times. Did you know you were going to shoot a guy with in a wheelchair tonight? Misadventures, has anyone looked at the occurrence of carpal tunnel syndrome when plotted against introduction of NES? Man, we spent so many hours on these stupid controllers. Oh, not ergonomic in any way. Oh, there you go. Oh, there you go, number 2. That's all right. 1 more shot, and then he's going to drop a gold card, and then you're done with this level. And then eventually you're going to have to do a jump rocket. So it's something you might want to practice now. Kill the things on screen, do a jump. Oh, never mind. All right, number 3. So wait for him. He's going to dissolve, and he will reappear as a gold card, because that's how physics works. All right. Is that condensed matter? That's turning carbon into gold.
Transmutation.
Transmutation. There we go. All right. So now what you're going to want to do is go to the top of the screen. You're going to jump and try to rocket him in the hat. And when you do that, it'll get rid of his sunglasses. So top of the screen, very top of the screen. Go further up. And then you're going to tap B.
B.
And then a rocket on the way down. Yep.
A rocket on the way down. Okay.
Yep. And so he's going to kill you, and you're going to want to run this way because this gets hard. Run to the right. Stay on the top of the screen. Turn back, jump rocket, get away from him, do it again. You have a bunch of room on both sides of it, so you'll run out of room here.
I lack the necessary.
Yep, suppress it a little lighter. All right, Cyprian is at the rate-limiting step of beating NARC. Every guest comes across this one, and the sequence of jumping and shooting the rocket is non-trivial. So if you guys have questions, this is your last chance to ask Cyprian about them. Whether it's condensed matter, physics in general. He is happy to answer those. Oh, that was close. So you're going to tap B, and then on your way down, you'll tap A. Yeah, that one was really close. A little too long on the A button tap. If it doesn't shoot anything, it's because it was too long.
Oh, wow. So it needs to be like really lightly. Okay.
Yep. So go to the right, get some distance. You have plenty of room to the right here.
Okay.
So like turn back now, jump rocket, don't run towards him. There's no advantage in running towards him. You want him to come to you.
But I can shoot from a far distance?
Yep. So that was pretty close. A little later on the rocket. So yeah, then get some distance this way. If he comes close to you, run away from him is what I recommend. Everyone's on the edge of their seats. All right, turn back. So stop moving, jump rocket. Go ahead. Pretty close on that. Run away. Run away to the right.
Sorry.
Either way. No, it's up to you. I don't care. I'm just giving you jump rocket. Yeah. So yeah, he's going to be on top of you. Go to the right. Jumping is a good strategy. So get some distance. Turn around, make 1 attempt. So stop there, right there. And then jump rocket. A little later. Oh, that was really close. Now run away, the right or left, either one. Do that again. That one was really close, actually. A little bit later, and that would have been perfect.
Only 1 shot?
Yep, 1 shot to the hat, and then it'll be a different phase. So then you don't have to jump on the next one.
Do you find that people do it eventually, or do you give up?
Sometimes people give up, but it's after like 10 minutes to try. You were pretty close on that one, so jump, do it. Pressing the A a little too hard. Run this way.
Sorry.
Yeah. So you can get several tries if you run that way, because you have a lot more room. So turn around, jump. Oh, that was close. A little later on the button. So go right. Misadventures is rooting for you.
Thank you.
All right, so turn around.
Okay.
Stop there. Stop there. Turn around. Jump. Tap the jump. A little later on the A. A little later on the A.
And
then go right. Go right. Get yourself some room. There's a bunch of space on this side, so you can get like 3 tries of that. So now turn around. Jump. A little fast on the A button. So the rhythm is like B, A.
We are on Albert Einstein. Everyone knows the quote about definition of insanity.
Yeah, exactly. So try something slightly different. A little later on the A button.
I don't know if I'm doing this wrong with the... I think I'm pushing too hard.
Yeah. If you push too hard, it won't shoot something, or it'll shoot a bullet instead of a rocket. So you have basically 1/10 of a second on the B tap, 1/10 of a second on the A tap. Turn around. That was really close. A little hard on the A. So run away again. Try it again. The definition of insanity. Are you living the dream right now?
At least I got the...
Oh man,
right?
so we're closing out. We have about 5 to 10 minutes left. Is there a question I didn't ask you that you wanted me to ask?
No, I think it was very interesting.
Yeah.
I hope that I didn't lose focus too much.
Oh no, that's part of the game. That's why we do it, right? The humanizing aspect. So go to the top of the screen so the tongues don't hit you.
Oh, so they don't hit me in the...
Yeah. Oh, this is one we didn't cover. What is the Earth is flat? There. Okay, rockets to the face now. There you go. Okay, so now what you're gonna do? Run away from him. Go between these 2 black lines. And you're gonna turn back and you're gonna shoot bullets.
Okay.
So turn back and move up and down while you're shooting bullets. That'll kill his vertebrae over time. So run away. Do the same thing again. So get between those 2 black lines. Turn around when he puts his head down.
So it's only when he puts their head down?
Yep. So there, you saw those 2 vertebrae. Now you're going to go the other way and do the same thing. Just repeat that process. So anti-vax, Earth is flat equivalent. I guess Earth is flat might apply to physics in general. But is there something you've heard or some common misconception? Okay, so turn around, stay in that range.
In physics.
Yep. Condensed matter or otherwise, so hold A.
So a common...
So no more rockets, bullets only. Walk away.
So the common misconception is that people don't believe...
Hold A. Hold it. Hold it.
I'm sorry.
Yeah. There you go. Move up and down and you'll hit the vertebrae.
So common misconception is special relativity, and people come up with many different theories.
Oh, there you go. Go right.
People come up with many different theories for special relativity. It's very rarely that they come up with a theory for general relativity. They typically come up with a theory of special relativity, and there it is.
Go right. Come across the door.
So there are some, that special relativity is a conspiracy theory, and we are not telling everyone what's the real evidence, that maybe Michelson interferometer experiment wasn't right. So
so the ether is real.
That's right. The real. So that I think is the... Okay.
You did it.
Okay.
Congratulations. Your time is 20 minutes and 54 seconds.
So what was the normal?
Man, let's see where you sit on the spectrum. If you guys have suggestions on people we should raid, draw curiosity. That's fun. I don't think we've raided them before. All right, let me look up where you sit on the spectrum. You get to put your initials in.
C Y E.
All right, so on the spectrum, 20. You are top 17
That's not.
of all people. This is like, I don't know, roughly, how many is that? 70 some streams.
Okay.
You are top 17.
Okay.
Of the physicists, you fall behind Christian Beekman. I forgot
Nice,
she was on
Christian.
stream. No, she did 2046, so she beat
Nice.
you by 8 seconds. Oh no. Next up, Ted Kohlberg, 2222. Maya Murphy, 2323. Where else? Do you see another physicist? Oh, Take was
Take,
on. I forgot it.
2819.
2819. I've had a lot of physicists on. David Collins, he had some assistance at 3048. Hitesh needed some assistance. Hanwei and Rachel. I think that's it for physicists. So congratulations. You are only losing to one of your colleagues.
Up to here.
Oh man. Was that everything you hoped it would be?
It's
So you said you're a PC gamer, not a console
That's
gamer,
right.
but you
Yes.
had to pick up a controller for this one in
That's
particular.
right. Yes. Yes.
All
This
right.
is my one and only time, and I am proud of my achievements.
You bragged to Hitesh at the
That's
very
right.
least.
That's
Tell him you dominated him in Ask a Scientist Gaming. So, congratulations. We're going to find somebody we can raid. I think Astro had a suggestion. I will keep track of that. But thank you all for joining us. Another stream of Ask a Scientist Gaming. It's been a pleasure. It's always great having you guys ask questions. Cyprian, I mean, you played some Counter-Strike for the first time in like a couple decades, won some games, even played against non-NPC players. You played some Dragon Ball combat fighting. You learned how to win that. You won the war on drugs and talked some science. How are you feeling right now?
It was fun. Thank you very much for inviting me, and thank you for the audience for asking the questions.
Any parting words for the audience? Any knowledge you'd like to impart on them? Anything they should know about your field that you'd like them to know before we bail and go raid somebody?
It's just, I would say that condensed matter doesn't have a good press, because everything that we come up with leaves from condensed matter to engineering. So don't give up on us. We are doing good work.
Yeah. No, that's true. Astrophysics, you can look to the sky. Particle physics, I mean, smashing stuff fast is sexy, but all the detectors are based on things in condensed matter physics. So respect the discipline. All right. Well, Cyprian, thank you again for doing this. We met at a meeting for MRSEC proposals, and we just started talking, and he was like, oh, yeah, I'll play video games. And I'm really glad you did. Thank you for accepting the invite. We had to troubleshoot some video gaming, but we did. It worked out amazingly. And congratulations on your time in NARC. You have bragging rights for almost everyone in physics except for Beekman. So you got that going for you. All right. Thank you all for joining us. Next stream is actually going to be next week, and the guest is going to be me. And so we have a special stream every single year. It happens in November. We do a Q&A about graduate admissions and applications and all sorts of things. This is kind of part of our recruiting effort for getting students to try to come to FSU and do chemistry. And so I am going to be the guest because I'm the chair of the graduate admissions committee in the Department of Chemistry and Biochemistry. And so I will get to play video games while answering questions. The host is going to be Dr. Eugene DePrince, who is a colleague in my department, theoretical chemist. He does quantum chemistry and things like that, does programming. But yeah, I will be the guest. I'll be happy to talk about photochemistry and also about graduate admissions. We're going to invite a whole bunch of prospective students to come ask questions if they have them. And I'm going to play a little bit of, NARC will be on the list for sure. Probably some Super Mario Maker. I also got a new toy, which is a light gun for a LCD screen. So I'm going to play a little bit of Area 51. I don't know if you remember the arcade game Area 51, and also some Jurassic Park. And so, yes, I'm getting demoted to guest next week, but hopefully you guys will join us and you'll get to ask me any questions you want, as well as we'll hopefully educate some people about graduate admissions. But again, it's always a pleasure. Thank you all for stopping by. It's been a lot of fun questions. And Cyprian, again, congratulations on winning the war on drugs and beating your colleagues in NARC. What about the weird surgery game? Oh man, so should we do some Surgeon Simulator? Lori, remind me next week we need to do some Surgeon Simulator. That sounds like an excellent time. But until then, we're going to raid somebody, educational streamer. I think Misadventures had a suggestion, which we will reach out to shortly. So stick around. Let's bring our people to other education related streamers. Thank you all. It's been a lot of fun. Yeah, until next time, we look forward to seeing you guys then.